Yes, I guess we are live today. Hello, my dear audience, and welcome to our day two of Geekle AI Transformation Summit. This day is focused on technologies, it's focused on development, dev tools, architecture, everything that actually behind delivery. And we, as I mentioned yesterday, and probably the audience already get it, but I will not stop repeating this because our mission is to equip our community with the best use cases of using AI, implementing AI in software development lifecycle. That's our mission for 2025 at Geekle, and that's why we're all here. I hope you enjoyed yesterday our great event, great day focused on product. We heard lots of cool stuff about marketing, about user analysis, about safe using or implementing Gen AI and stuff. And yeah, probably we should move today to our next sessions. As always, I will remind you the rules. I would like As always, I would love to remind you our rules. So you are watching this session, asking questions in chat, following speakers, and trying to get what you can actually get from AI today, how you can get stronger. So let's move to our very first speaker. Without further ado, Alexander Karmagolin, self-healing multi-agent systems implementing autonomous recovery in distributed AI. Let's go.
Hello everyone, my name is Alexander and I am AI engineer at Logic Boost. Today we are going to explore how to build multi-agent systems that can effectively detect their own failures and autonomously recover from them. In the next 30 minutes, I will show you practical techniques for implementing self-healing mechanisms in production LLM-based systems. Let's get started. Traditional error handling relies on well-defined exceptional types and predetermined recovery paths. But LLM-based systems introduce unique failure modes that are semantic in nature, often subtle, and potentially catastrophic if left undetected. Unlike conventional software, where errors trigger exceptions, LLM agents can continue operating while generating increasingly degraded outputs. A system might appear functional while experiencing cognitive failures that traditional monitoring won't detect. Here's what we'll cover today. First, we'll examine the unique failure modes that occur in LLM agent systems. Then we'll explore a three-tier architecture for self-healing. Next, I will share you implementing details with practical coding patterns. And finally, we will review performance metrics and real-world impact. By the end, you will have practical techniques to dramatically improve reliability and before we can implement healing mechanisms, we need to understand what can go wrong. In our production deployments, we've identified 5 primary categories of failures in LLM agent systems. Prompt hallucination occur when agents confidently generate fictional information, like citing non-existent research papers or inventing API calls that don't exist. Context window overflows happen when critical information falls out of the limit token context. Semantic drift manifests as agents gradually losing focus on their original objectives. Coordination failures appear in multi-agent systems when agents develop conflicting data representation or deadlock waiting for input. And finally, errors propagation occurs when minor reasoning errors cascade through connection agents. What makes this particularly challenging is that they often don't trigger traditional monitoring alerts. Your system appears operational while delivering increasingly unreliable results. Let's examine the 3 main ways our AI agents fail in real-world settings. First, hallucination. As you can see in this example, we have a chatbot interface where the agent is confidently generating false information. This happens when agents invent facts, cites on non-existing sources, or create plausible but incorrect responses with high confidence. Next, context overflow. In this scenario, we have how critical instructions given earlier in the conversation are forgotten when the token limit is reached. Notice how the agent has lost track of the original categories and constraints, causing it to produce increasingly irrelevant outputs. Finally, coordination failure. This third image illustrates what happens when two agents develop conflicting representations of the same data. The arrows show how these agents are unable to reconcile their different models, leading to inconsistent decisions and system-wide failures. These visual examples demonstrate why traditional monitoring is not enough. These failures don't trigger conventional alerts, but gradually degrade system performance. Our approach to self-healing implements a 3-tier architecture. At the foundation, preventive mechanisms establish robust system design patterns that minimize failure occurrence. The middle layer consists of detective mechanisms that continuously monitor for semantic and coordination failures. And the top layer implements corrective mechanisms that autonomously recover from detective failures. This architecture draws inspiration from site reliability engineering principles, but adapts them specifically for the unique characteristics of LLM-based systems. Rather than focusing solely on infrastructure metrics, our approach monitors the semantic health of agent cognition in interactions. The key insight is that many failures can be prevented. through careful architecture design, but we must also assume failures will occur and implement robust detection and recovery systems. Let's start with prevention. These architectural patterns significantly reduce failure rates before they occur. First, prompt engineering best practices, like using clear instruction, examples, and structured outputs, reduce hallucination rates. Agent specialization limits the scope of each agent's responsibilities, reducing cognitive load. Implementing chain of thought validation creates checkpoints throughout reasoning processes. Efficient memory management with hierarchical summarization prevents context overflows. Here is simplified code snippet showing how we implement specialization and validation checkpoints in long chain. These preventive patterns alone can reduce failure rates by 60–70%, but they are not sufficient for production reliability. The detective tier continuously monitors for signs of agent cognitive failure. There are 5 key components to implement. First, semantic consistency validation confirms that agent outputs remain aligned with original instruction. Second, token utilization monitoring watches for approaching context limits. Next, response quality assessment validates outputs against expected patterns. Then, coordination verification ensures multi-agent systems maintain consistent, shared representations. And finally, validator agents independently verify key conclusion using different prompting strategies. The challenge here is implementing this without excessive overhead. Our implementation integrates monitoring hooks directly into long chain agents and uses lightweight validator LLMs optimized for specific detection tasks. In practice, we found that semantic consistency monitoring provides the highest ROI, detection approximately 70% of all failure modes with relatively simple implementation. This example demonstrates how we implement semantic consistency validation. We've created a monitoring wrapper that captures agent prompts and responses, then periodically validates that responses remain consistent with original instruction. Note how we are using a separate, optimized model for validation to minimize token consumption while maintaining high detection accuracy. In production implementation, we extend this with domain-specific validation rules and integrate telemetry. Active tier implements autonomous recovery. Here's what happens. First, the system captures the current state and failure signature. Then it classifies the failure type to determine the appropriate recovery strategy. Next, it implements the recovery action, which might include automated prompt refinement that strengthens guardrails against detected failure patterns, dynamic context management that rebalances token allocation, agent reinitialization with optimized instruction, failed components isolation and rerouting. Finally, it validates recovery success and logs the incident. Here is simplified implementation. The key innovation here is that recovery includes not just restarting components, but actually improving them based on the specific failure patterns detected. The system learns from its failures. Implementing effective self-healing is not easy. Here are the most significant challenges we've encountered. The metacognitive monitoring paradox involves using LLMs to validate other LLMs, creating potential blind spots if they share the same limitation. We address this by using specialized validation models with different architecture and prompting strategies. Detection accuracy challenges include managing false positives that trigger unnecessary recoveries. Our solution implements confidence thresholds and graduated response strategies based on failure certainty. Resource efficiency trade-offs are significant. Comprehensive health checking can consume more tokens than primary agent functions. We address this through selective sampling and lightweight validators optimized for specific failure modes. Recovery mechanism design must preserve critical state during recovery. Our approach implements state isolation patterns that maintain memory while replacing reasoning components. These challenges require careful engineering and domain-specific adaptation, but the return on investment is substantial. So, what's the impact of implementing these self-healing mechanisms? Our benchmarks show dramatic improvements across all reliability metrics. Mean time between failures increased 6-10 time from 80-20 hours to 72-96 hours. Recovery time from context overflow improves from 15-30 minutes of manual intervention to 30-60 seconds of autonomous recovery. Hallucination rates in long sessions drop from 18-25% to just 3-5%. Task completion rates in 20-hour sessions improve from 60 to 78% to 94-97%, and semantic drift incident decreased by 80-85%. While token consumption increases by 15-30%, due to monitoring overhead, the cost per successful task actually decreases by 25-30% because of the dramatically higher compilation rates and reduced need for human intervention. Perhaps most importantly, human intervention rates drop from 1 in 20-25 interaction to 1 in 150 to 100 interaction, represented in 85-90% reduction in operational overhead. Let's look at a real-world implementation. A financial services company implemented these self-healing mechanisms in their document analysis agent system, which previously required frequent human intervention. Before implementation, they needed analyst review for 28% of all outputs, which averaged downtime of 4.2 hours per week. After implementation, they reduced analyst review to just 5% of outputs, with downtime reduced to 22 minutes per week. Despite 20% higher initial infrastructure costs, they achieved a 320% return of investment over 6 months. The largest gain came from automated context management and semantic consistency validation. What's particularly notable is that the improvement accelerated over time as the system learned from and adapted to the specific failure patterns in their environment. Based on our experience, here is a practical roadmap for implementing self-healing in your own systems. Start with robust monitoring before attempting recovery. Implement semantic consistency validation first. It provides the highest ROI with the simplest implementation. Begin with manual review of flagged issue, then gradually automate recovery as you gain confidence. For the tool stack, we recommend LangChain and CrewAI for the agent framework. Both provide solid foundations with built-in support for monitoring hooks. Lightweight models like Llama or Qwen or small GPT variants for validation. You don't need the same model size for validation as for primary tasks. Integration with your existing monitoring infrastructure for telemetry. A hybrid approach for both vectorized and structured storage for state management. And container-based deployment for selective components restart during recovery cycles. The goal is not to reinvent your entire stack, but to augment it with specialized self-healing capabilities. As you implement these patterns in your own system, here are the most important takeaways. Focus on semantic monitoring is the foundation of effective self-healing. Implement preventive patterns first. They provide the highest ROI for implementation effort. Create specialized validator agents rather than trying to make production agents self-validate. Preserve state during recovery using isolation patterns. Start with human-in-the-loop recovery and gradually automate as confidence grows. Collect and analyze failure patterns to continuously improve detection accuracy. Implement graduated recovery strategy based on failure severity and confidence. Maintain comprehensive telemetry throughout the recovery process. These patterns can be implemented incrementally, allowing you to improve reliability without a complete system redesign. As LLM-based systems become more critical to business operation, implementing a robust self-healing mechanism is not optional; it is essential for production reliability. The three-tier architecture we've explored today provides a framework for thinking about autonomous recovery in cognitive systems. By combining preventive architecture, detective monitoring, and corrective adaptation, we can create systems that not only detect failures, but continuously improve their resilience. Looking forward, we are exploring more sophisticated approaches to failure prediction and preemptive adaptation, but the patterns we've discussed today provide a solid foundation for current production systems. Thank you for your attention. I'd be happy to answer any question about implementing these patterns in your specific environments.
All right. Thank you, Alexander, for the deep dive into Python. And self healing is actually a thing. This startup that actually boomed lately, Lovable, their thing were actually self healing or unstocking, how they say, when agent stuck somewhere, they found a way to unstuck this agent and something like that. Thank you very much. And we're moving to our next speaker, Denis Prulevsky, AI driven data architecture for real time decision making in enterprise systems. Please ask questions in chat and enjoy the session.
Hello, everyone, and thank you for joining me today. I'm Denis Prelevsky, and I'm excited to take you through an important topic at the intersection of real-time data architectures and AI-driven decision-making. This session is designed as an overview for a broad audience. Whether you're new to real-time AI or already working with data pipelines, you'll find valuable insights here. We'll keep a balanced approach, technical enough to be useful, but without diving too deep into code or niche implementation details. Our focus today is on how enterprises can move from batch to real-time AI, enabling instant decision-making. We'll discuss architectural principles, key technologies, real-world case studies, and best practices to help you think about applying these concepts in your own organization. Let's get started with why real-time decision-making matters. So, imagine you're a bank's fraud analyst. A suspicious transaction pings the system. If you can flag it immediately, you block the card before more damage is done. If you only find out hours later, the money may be gone. Or picture a manufacturing plant. A machine's sensor detects an anomaly. Catching it within seconds allows an instant fix to prevent a breakdown, whereas discovering it even in 30 minutes later might mean expensive downtime. In cases like finance or operations, speed is absolutely crucial. Traditional batch processing, where data is collected and analyzed in hourly or daily cycles, is too slow for such scenarios. Many modern use cases demand decisions in real or near real time. Take online advertising. An AI system often has to decide which advert to show you in about 50 milliseconds, roughly the blink of an eye. Humans or overnight jobs can't react that fast. In general, combining live streaming data with AI in the loop enables automated decisions as events happen. This unlocks use cases across industries. From finance to retail to security to IoT, where reacting in seconds or milliseconds is critical. Companies that leverage their data instantly gain a real competitive advantage. However, working in real time comes with challenges. You must handle the velocity and volume of incoming data, while keeping latency extremely low. You need strong reliability so you don't miss events or trigger false actions. And you must deal with a variety of data types, structured logs, unstructured messages, and so on, and ensure data quality on the fly. These are non-trivial tasks, but the payoff is significant. For instance, one company's adoption of real-time AI analytics reduced certain report processing times by 40%, allowing much faster business responses. The message is clear: the ability to make decisions right now can be a game changer. So, before diving into the architecture itself, let's outline the core technical challenges we face in building real-time AI systems. These challenges define what our architecture must handle. So, first one, throughput and latency. We often need to process massive event streams, potentially millions of events per second, and still respond within sub-second times. High throughput with ultra-low latency is tough to achieve, but the system can't afford bottlenecks. Data variety and quality. Enterprise data comes in all shapes and sizes. Our architecture must ingest structured transaction records, semi-structured logs, even unstructured text or sensor signals. Handling different formats and evolving schemas while maintaining data quality is essential. Just remember, garbage in, garbage out. Next one is reliability and consistency. In real-time pipelines, we can't lose duplicate events. We need exactly once processing guarantees despite system faults or restarts. Fault tolerance, orderly processing of events, and consistency of data are critical, especially if automated decisions like blocking a payment are on the line. Scalability and availability. In this part, the architecture must scale horizontally to accommodate growing data volumes or spikes. This typically means leveraging cloud infrastructure or for some flexibility. Also, it must be highly available. Downtime or slowdowns in a real-time system can directly translate to missed opportunities or failures. These challenges set a high bar. To meet them, we design an architecture with components and technologies specifically tailored for speed, scale, and smarts. Let me paint the pictures of what such an architecture looks like at a high level. Think of a pipeline that starts with raw data events and ends with actionable insights, all within perhaps a fraction of a second. For example, raw inputs flow into an ingestion layer at high speed. From there, they stream into a processing engine and can handle events continuously. We might buffer events in a durable queue briefly, but only to quickly hand them off to an analytics AI engine that computes results on the fly. The processed data or predictions are then immediately sent out to any part where they are needed, perhaps updating a live dashboard, feeding into an automated alerting system, or triggering some business action. All of this happens continuously for each incoming event. In the next slides, we'll discuss two main architecture patterns and break down the components of this pipeline and the tech choices that allow us to achieve these real-time capabilities despite the challenges. So, when building real-time data architectures, two main design patterns emerge: Lambda and Kappa architectures. Both aim to process large-scale data efficiently, but they take different approaches. Let's break down their key differences and when to use each of them. So, Lambda architecture. The hybrid approach, Lambda was designed to balance accuracy and speed by splitting data processing into two layers. Batch layer periodically processes historical data, ensuring accuracy and completeness. And speed layer handles real-time streams for immediate insights, but with approximations. So server layer merges results from both, providing a combined view. This approach is useful when both historical accuracy and real-time insights are needed. However, maintaining two separate pipelines increases complexity, and batch processing introduces delays before final results are available. In case of Kappa architecture, Kappa simplifies this by eliminating the batch layer and treating all data as stream. Instead of maintaining separate processing paths, the system continuously ingests and analyzes events in real time, replaying event logs when needed for historical analysis. This makes the architecture simpler, more scalable, and truly real time. However, reprocessing all data can be more challenging compared to batch-based approaches. Choosing the right approach, we should consider that use Lambda when historical corrections, strict accuracy, or compliance reporting are critical. And we should use Kappa when real-time insights and low-latency decision-making are the priority. The key takeaway here is that Lambda has been widely used, but Kappa is emerging as the preferred choice for AI-driven real-time systems. By simplifying the architecture and reducing duplication, Kappa aligns better with modern event-driven data processing, making it a strong fit for AI-powered real-time decision-making. Let's dissect the architecture of an AI-driven real-time data system into its core components and typical technologies, seeing how data flows and where AI integrates under the hood. We started from data sources. These originate events as continuous data streams from website click streams, IoT sensor readings, or transaction logs. Examples include user activities on an e-commerce platform or sensor data from a manufacturing plant. Event streaming ingestion. We ingest and forward events rapidly using high-throughput distributed logs or message brokers like Apache Kafka, a scalable queue managing millions of events per second. Kafka provides a durable buffer, ensuring events are reliably stored and delivered in sequence, allowing replay or reprocessing if needed. Stream processing and AI analytics. This is the brain. Frameworks like Apache Flink or Apache Spark Streaming perform real-time analytics and embedded AI models. Flink enables stateful event processing with exactly once guarantees and manages late or out-of-order events using timestamps. Here we aggregate, filter, detect patterns, and apply ML models either inline for immediate inference or via external services. Lighter frameworks such as Kafka Streams may handle simpler analytics directly within Kafka. Feature store. Effective AI decisions require context beyond single events. For instance, recent transaction counts for fraud detection. Feature stores or fast databases like Redis or Doris hold pre-computed, quickly retrievable state or features, ensuring models access timely data without latency bottlenecks. AI models serving. Machine learning models infer life via using two patterns, in-stream or external service. In-stream models embedded in the processor, for example Flink, ensure ultra-fast inference without network latency, suited for simpler models. External servers, for example TensorFlow or NVIDIA Triton, manage complex models separately, optimized for fast, low-latency inference, critical in applications like real-time fraud detection or anomaly analysis. Storage and real-time analytics. Processed data often flows to storage systems, optimized for rapid querying, Apache Druid, Apache Pinot, or ClickHouse, to power dashboards or analyst queries on recent data. Through outside immediate decision loops, these systems support real-time monitoring, human-in-the-loop decision-making, and AI oversight. Finally, insights or actions generated by AI reach their consumers swiftly. Automated business processes, alerts, or interactive dashboards. Results often triggers immediate responses, such as blocking fraudulent transactions via banking APIs or alerting maintenance technicians. The architecture ensures minimal delay from data ingestion to actionable insights, closing the feedback loop. In short, the continuous data stream moves rapidly through Kafka, processed intelligently by Flink or Spark, producing instant actionable outcomes where needed most. Each component is carefully chosen for speed, scalability, and reliability in managing real-time AI-driven decision. So, building a working pipeline is one thing. Making sure it operates optimally at scale is another. Here are a few key considerations and best practices to ensure our real-time architecture runs smoothly under heavy load. First of all, it's partitioning. To handle high throughput, we partition data streams and process in parallel. For example, Kafka topics are split into partitions and stream processors run many parallel tasks. Proper partitioning strategy is crucial. And is crucial to distribute load evenly. This ensures no single node is overwhelmed and we utilize cluster resources efficiently. It also allows linear scaling. Need to handle more events, add more partitions and processing nodes. Next one is exactly once processing. We've already discussed this approach, but let's repeat. We should ensure that we are working and processing with one event only once. And anyway, we should stay with only one processing for one event. Next one is latency optimization. We using in-memory data stores like Redis and avoiding disk where possible, keeping data transformation lean and possibly simplifying machine learning models so they run faster. Techniques such as model quantization or using faster inference hardware, GPUs or TPUs can reduce model latency. We also configure our stream processors with the right settings, which allows us to optimize the stream. All these tweaks ensure we meet strict latency targets. Monitoring after scaling. Real-time systems require real-time monitoring of their own. We put in place dashboards and alerts for the pipeline's health, processing throughput, memory usage, and end-to-end latency. If latency starts creeping up or throughput spikes, we might need to scale. Cloud environments allow adding instances automatically. So we set up auto-scaling rules and add more processing power if, say, incoming events surge during peak business hours. In essence, optimizing a real-time AI pipeline is about staying ahead of bottlenecks. Partition data, use the right tools to guarantee reliability, fine-tune for low latency, and watch it like a hawk in production. With this in place, we can trust our architecture to handle real-world demands. Now, let's see some real-world examples of these principles in action. Well, nothing beats a real example. Consider a large bank implementing real-time fraud detection using AI-driven data architecture, highlighting practical integration and tangible benefits. The bank aimed to detect fraudulent transactions instantly to prevent financial losses. Timing is critical. Catching fraud as it happens blocks losses effectively, whereas delayed detection via batch reports often comes too late. The requirement is to analyze each transaction in real time and with an AI model and immediately take some action. From the architecture point of view, an event streaming pipeline was established with every transaction, card swipe, online payment, and so on, streamed instantly into Kafka, creating a real-time transaction feed. A stream processor, Kafka Streams and Apache Flink, immediately consumes these events, correlating them with recent account behavior and known fraud indicators like unusual location or transaction frequency. This processor maintains state or quickly retrieves contextual information from a fast database or feature store. In the same time, an AI fraud detection model trained on historical fraud data scores each transaction's risk, either embedded directly within the stream processor or assessed via a microservice. The model uses live transaction data plus aggregated features like transaction frequency within the last minute to predict fraud probability in roughly 50 milliseconds per transaction. If the AI model and the business logic detect high fraud risk, the system instantly generates an alert and can automatically halt the transaction within seconds. The architecture leverages Kafka durability and partitioning capabilities to reliably handle thousands of events per second. Exactly once processing ensures transaction accuracy, preventing duplicates and missing events. Stateful stream processors like Flink aggregate data swiftly, essential for identifying rapid transaction patterns indicating fraud. Customer data and account context reside in a fast feature store, allowing instant retrieval. The ML model is optimally served using in-memory TensorFlow serving achieving about 50 milliseconds latency, ensuring swift, accurate predictions. By adopting this real-time AI-driven architecture, the bank significantly reduced fraud losses and achieved uh, fast fraud detection, greatly enhancing customer trust. Suspicious transactions previously missed in batch systems are now immediately flagged and prevented, often before customers themselves notice an issue. Uh, so this approach mirrors industry-leading practices. Companies like PayPal also deploy real-time graph-based ML to detect fraud within milliseconds, validating the effectiveness of combining Kafka, streamlining analytics, and ML in financial fraud prevention. Our second case study examines predictive maintenance within an IoT setting, leveraging AI and streaming data to forecast equipment failures, enabling real-time operational decisions. So, picture a large manufacturing or automotive plant with thousands of sensors constantly emitting data, temperatures, vibrations, pressures, and error codes. By analyzing these data in real time, early signs of machine failure can be identified, allowing immediate interventions or operational adjustments. Predicting failures before they occur significantly reduce costs by preventing unexpected downtime and improving maintenance schedules. This system closely follows the pattern previously outlined. Sensor data continuously streams into a central Kafka-based event bus, handling thousands of events per second. Kafka reliably buffers orders and distributes sensors events instantly. A streaming analytics engine consumes and processes this data in real time. Processing involves tasks such as anomaly detection, for example, computing rolling averages of machine vibrations and comparing them to normal operational thresholds. Flink handles this by using event time windows and watermarks, efficiently managing out-of-order sensor events. Aggregated features feed into predictive ML models such as regression or classification algorithms trained on historical data, predicting imminent failures. These systems adopt a CAP architecture, managing both real-time and historical processing in an unified streaming pipeline, simplifying operations by enabling historical event reply without separate batch systems. Scalability remains vital. Kafka supports high-volume data bursts, while Flink ensures accurate processing despite event time. Recent metrics per device are stored in online feature stores or Time series databases like Apache Pinot, supporting rapid model inference either directly in stream or through lightweight microservices optimized for latency. Upon detecting a high risk of failure, the system instantly triggers actions, alerting maintenance engineers with details or automatically adjusting machine settings to prevent damage. Real-time dashboards display predictions and anomalies for operational monitoring, with data also archived for trend analysis and continuous model improvement. The adoption of real-time predictive maintenance shifts operations from reactive to proactive, significantly reducing costs associated with downtime. Kafka-driven architecture successfully scaled for over 100,000 devices, providing immediate detection and proactive mitigation. So, this case demonstrates that the core architectural principles, event streaming, rapid processing, integrated AI, extend effectively beyond digital environments into tangible industrial applications uh, and enabling smarter, proactive decision making. Implementing real time AI architecture is a journey. Drawing from industry experiences and our case studies, here are best practices to guide your approach. First of all, design a unified data strategy. Prevent data silos by consolidating streams into a central platform like Kafka, ensuring different teams' data sources interconnect seamlessly. Determine clearly which use cases require real-time versus batch processing, focusing real-time efforts on areas where immediate responses provide the top business value. The next one is data governance and security prioritization. Effective governance remains critical even in fast-moving streaming environments. The same thing is actual for security. So all the necessary things should be in place, like ensuring APIs have robust authorization protocols and comply with the relevant regulations. We should ensure scalability and resilience. We should architect our system for scale from inception, using technologies proven for large-scale performance like Kafka or NoSQL databases. Uh, we should design for failures by implementing resilient mechanisms such as replication, exactly once processing guarantees, and automated health checks and failovers to maintain pipeline some pipeline continuity around the clock. Align AI models with data streams. Closely integrate your data architecture and AI workflows by practicing effective MLOps. Use feature stores to consistently deliver features across training and inference scenarios. Continuously monitor model accuracy and latency, retraining or tuning proactively. Incorporate a feedback loop where model outputs refine future iterations, viewing AI components as dynamic evolving systems. Next advice is start small and iterate. Avoid overly ambitious in initial deployments. Begin with a narrow, focused use case or pilot, such as streaming data from a single production line or regional credit card transactions, to quickly prove value, manage technical complexity, and build stakeholder support. Once stable, gradually add more data sources, use cases, and advanced analytics or AI models, incrementally increasing sophistication while minimizing risk. Next one is cross-functional collaboration. Real-time AI systems span multiple organizational functions, IT, data science, business operations, and more. Early and ongoing collaboration across these groups ensures alignment of business requirements and technical capabilities. Invest in developing specialized skills such as stream processing and ML ops within your teams, enabling smoother execution. Following these guidelines, unified data strategy, robust governance and security, scalability and resilience, MLOps integration, incremental implementation, and cross-functional framework will boost your likelihood of success, delivering maintainable and strategically available real-time AI solutions. As we come toward the conclusion, here are the key takeaways from our exploration of AI-driven data architectures for real-time decisions. So, real-time AI is a competitive advantage. Moving from batch to real-time processing can significantly reduce decision latency and unlock new levels of automation and responsiveness. Organizations that embrace event-driven intelligence can act on information faster than those stuck in periodic processing. In today's fast-paced environment, that speed can be the difference between seizing an opportunity or missing it. Real-time AI is becoming a competitive must-have, not just a nice-to-have. Architecture matters. To achieve real-time AI at scale, a robust architecture is non-negotiable. Event streaming platforms, stream processors, feature stores, and fast model serving all play a role. The specific tech might vary. Kafka versus others, Flink versus Spark, and so on. But pattern is consistent. Careful architectural design, like using a unified streaming pipeline, reduce complexity and improves efficiency. Our case studies showed that the right architecture directly translates into business outcomes. So invest in the architecture. It's the backbone of success. Data and AI integration is key. It's not just about having streams and having AI. It's about integrating them effectively. Ensure your data is feeding the AI models with the right features in real time, and ensure your AI outputs are fed back into business processes promptly. In summary, your data engineering and AI teams need to work in tandem. One without the other will not deliver the full value. Plan for reliability and scale. Real-time systems are complex distributed systems. Things will fail if not planned. Whether it's a spike in load or a software bug, our takeaways: built-in partitioning, fault tolerance, and monitoring from the start. You want a system that can handle a node going down without dropping data, and one that can recover and catch up if there is some significant error. Also think about operational aspects. Who monitors the dashboards at 2 a.m. if an alert triggers? The technology and operations must be aligned to truly achieve real-time responsiveness. Because iterative improvement and finally realize that implementing AI-driven real-time decisioning is a journey. Start with targeted use cases that have clear ROI and expand. As you deploy, gather metrics, measure the impact, like how much faster decisions are or how much loss was prevented. Use those to refine the system and to justify further investment. Over time, as new frameworks and best practices emerge, be ready to adopt them. In essence, Real-time AI-enabled data architecture is powerful. It enables business to act instantly, automate a lot of processes, and scale seamlessly. But it requires aligning technology, people, and processes to overcome challenges. So, what next steps can you take after hearing this? First of all, assess your readiness. Evaluate your existing data infrastructure and identify areas still dependent on batch processing. Pinpoint specific pipelines or decisions where real time processing would add the most value, such as fraud detection, dynamic pricing, supply chain alerts, or personalized customer interactions. Engage business and technical stakeholders to prioritize valuable real time AI use cases. Start pilots with event driven architecture. Begin experimenting on a small scale with event streaming technologies. Um, Strengthen AI ML integration. Foster closer collaboration between your data and AI teams. Establish a feature store to facilitate consistent reuse of features between training and real time inference. Align model development closely with production streaming environments, considering containerized deployments or specialized model serving platforms. Plan proactively for monitoring models in production, focusing on both performance and accuracy. Develop monitoring and continuous improvement. Implement some observability for real-time pipelines, tracking technical metrics and business outcomes. Establish feedback loops to iteratively tune and optimize your system based on insights gained. Stay aware of emerging trends, tools, and methodologies in streaming AI, such as advancements in Stream SQL or integrated platforms that simplify messaging, processing, and AI integration. Uh, Educate and evangelize. Internally promote awareness about the value of real time AI. Cultural shifts might be necessary, especially if teams rely heavily on batch processes. Demonstrating quick wins through some initial dashboards and practical examples can build trust and adoption. Ensure end users, customers, or internal staff are ready to act upon real time insights effectively. So, AI driven architectures enable organizations to operate at the speed of their data. By integrating real time streaming pipelines and machine learning, enterprises can instantly respond to critical events, blocking fraud, engaging customers with timely interactions, or preventing operational failures. We have outlined the necessary architecture, key challenges, best practices, and potential rewards. Now it's your turn to determine where real time AI could deliver maximum impact and take concrete steps towards making it a reality. Thank you for joining this deep dive. I hope you found it insightful, practical, and motivating. Real time AI might appear complex initially, but with a clear strategy and incremental approach, it's well within your reach. Thank you again.
All right. Yes. Yes. Thank you very much, Dennis. Thank you very much. We understand this. It's a real transformation, and enterprises have to transform their data architecture, not just data, but all probably the architecture will be revised in few years because AI is here. Thank you very much, and I hope you are ready to our next insightful session from Manoj Kumar: AI and machine learning transformation in financial institutions. Well, let's do it.
Welcome to my presentation on AI and machine learning transformations in financial institutions. I will discuss how AI and ML are revolutionizing the financial industry, enhancing efficiency, security, and customer experiences. And together, we will explore applications, challenges, future trends, and real life examples of their impact on finance. So, as I said, I think we will be covering some key applications as well, and then we'll cover the future trends. So, today I will explain a bit on AI and machine learning, and then probably we'll move forward. So, artificial intelligence is basically about teaching computers to think and act like humans. It allows machines to learn from experience, make decisions, and even solve problems just like we do, but often much faster and with way more data. We see AI everywhere today, from chatbots that answer our questions to self driving cars and even recommendations on Netflix. It's changing how we interact with technology in ways we never imagined. The, there are multiple examples of AI like autonomous surgery, face recognition, self driving cars, chatbots, sentiment analysis, pattern recognition. When it comes to machine learning, it is a subset of AI, allowing subsystems to learn from data and improve over time. So there are two types of machine learning: supervised learning and unsupervised learning. So supervised learning is for those cases where we know the labels, we know the features, and we need to just classify. So you can classification of fraud detection or classification of COVID. Also, regression comes into this kind of learning. In unsupervised learning, we usually go for that unstructured data where we don't have the features. So we extract the features and then we make the model learn. So let's start by defining what artificial intelligence and machine learning are. I mean, in what ways they are revolutionizing the financial institutions. So their broad level, there are around four categories. How I mean, which are basically visible, or I would say, which have the more wide use cases. So one is like your automatic processes, enhancing your decision making, strengthening fraud detection, and personalizing customer experiences. So automating processes are like, this is more on the repetitive tasks which used to be done before, and they have been now automated by AI. Similarly, decision making has been enhanced by huge amount. So if you really look at it, banks and financial institutions, they have huge data, and they now can make decisions based on data for their customers and even for their employees. Similarly, with the help of AI, we have improved and strengthened our fraud detection models. And also, AI has customized and personalized the customer experiences. So we will cover these broad categories in detail in our coming slides. So I'm moving to the evolution of AI and ML in finance. So if you really look at it from historical perspective, right, in 1980s or even till 2000, we had rule-based systems for fraud detection and credit scoring. So back in those days, fraud detection was pretty basic. Banks would set up simple rules like if device changes, or if mobile number gets updated, or if transaction is unusually high, and then it will trigger some fraud alert that there could be a fraud. But these all rules were basic and static, simple, straightforward checks. So now, when AI came into picture, So AI powered fraud detection systems are like smart detectives. They learn and adapt as they go. Instead of just setting some rules, they recognize patterns, catch unusual behavior, and adjust in real time. So that's the beauty, that you don't have to wait for years to really make those models and again put in and then wait uh, for the results. Meanwhile, fraudsters, they basically become smart and they start doing different kind of frauds. Coming to the deep learning part of machine learning, so this is inspired from neural networks, and you must have heard natural language processing, which basically helps analyze documents, clean them, then get extract keywords from them, and based on them, making some decisions. Also, this is how Siri and ChatGPT can have conversation with us. So all due to natural language processing. So moving next, we need to understand that why financial institutions are adopting AI and ML. What is that uh, there are use cases for them, or they have to do it, or they are losing the race. So again, there are four broad categories why financial institutions are adopting AI and ML. So they have enhanced decision making, so which is nothing because they have large data sets, and they have, due to that AI, they now are able to credit score their customers in better ways than they had before, and also real time. Also, there are a lot of uses in investment strategies. Then, as we discussed, that they have also improved the fraud detection and cybersecurity. So this is again real-time monitoring. They do pattern recognition. They detect fraudulent activity very quickly, and then personalization of customer experiences. So if you really look at it, your AI chatbots, if you go to a bank site and when you talk to them, they gather your information, and then they talk to you like they have known you for years. So this personalized or customized experience, or what customers are getting, is essentially benefiting the banks or the financial institutions. The last part, and probably I would say the part which has been more discussed in the industry as of today, that cost reduction and the operational efficiency. Because a lot of repetitive tasks are being done by AI, and that is also leading to job losses, yeah, for some of the folks. So, but essentially, it is also adding, it is reducing the operational cost by basically removing a lot of hindrance from the old processes. So probably I think now the time has come to discuss the applications of AI, so that we can get more feeling that how the banking industry has been revolutionized by these applications. So if I go like if I take example of credit scoring, right? Credit scoring, because I have worked for I think probably more than 5 years in credit scoring, and that time we did not have AI, so we had to build static models. Right, we had fixed set of rules, and based on those rules, we would we would evaluate whether this customer deserves the loan or not, or he qualifies for the loan or not. But now, if you really look at it, so AI is making credit scoring smarter by analyzing not just traditional data like income and credit history, but also non-traditional sources like spending patterns and online behavior. I don't know whether you have heard of evidya. So they do that only. So some of the financial firms, they use data collected by evidya, or to really do calculations and provide unsecured loans. So that's how they are basically now checking the credit worthiness of the person. So AI is also revolutionizing risk management with predictive analytics. by constantly monitoring transactions and identifying potential risk in real time. For example, banks use AI to detect early signs of financial instability and prevent losses before they happen. Similarly, when we come to investments, so AI helps optimize portfolio management by analyzing market trends and suggesting better diversification strategies. So they provide, okay, which asset will perform better in coming months or coming years, or which asset may not do well. And also based on the portfolio of a client, they tell that what percentage of what asset you should keep in your portfolio. So now this is all data driven. So moving further, we will be covering another beautiful application of AI ML in financial institutions. So the fraud detection. So fraud detection, I think we gave uh, in, in the earlier slide. I mentioned that how it was static and it was basically prone to a lot of issues. With AI coming into picture, so you get the data real time. You when you in the real time you process the transactions, and then you real time from that data you recognize the patterns, and when you recognize the patterns, then you see. So essentially, I think what there are, if you look at it, there are multiple models which you can use. So you can use supervised, you can use deep learning model, or you can use unsupervised model. So among three, the unsupervised model plays a better role, because these models are great for detecting fraud when we don't have labeled fraud cases. Because see, fraudsters also learning every day, and then they're coming up with new strategies. So your system has to analyze and detect those patterns earlier and probably in real time. So instead of learning from past fraud examples, these models look for unusual patterns or outliers. For example, AI can flag suspicious transactions if someone suddenly starts making high value purchases in different countries, or if he makes transaction more than mean of last three more transactions, or she makes a high value transaction at odd hours. So essentially, if you really look at it, these three examples, right, and you compare with the old examples which I give, that the fraud was detected when devices change, mobile number change. This is like very trivial, and maybe may not be may not be the real time one, but these are all real time one, because we see the data, we look at the data, we see the different patterns, we see the change in the patterns, and then we detect it. So techniques like isolation forests and autoencoders help detect anomalies even if the fraud pattern is completely new. So this is the beauty of AI, that how it is basically helping banks, financial institutions to detect fraud. I think we will be covering one case study as well later on this similar thing. So moving forward to customer service. So customer service is like dear to a lot of companies, and it is like dear to many firms. So now I mean, before we had to wait for someone to respond to us, we put a query, and then we'll have to wait when the work when people will come to office or when work hours start. But now it is 24/7. You have AI powered chatbots or the virtual assistants, that you go to any site, they'll ask you, hey, how are you doing, do you have any question for me, right? So they understand and respond accurately to customer queries. So now, and then they also, as we discussed, they also have personalized recommendations, like algorithms analyze customer data to offer tailored financial products, enhanced customer onboarding, see, automated processes improving efficiency and user experience. So again, this is like very personalized experience what companies are, or like financial institutions are able to provide to their customers, which was not the case earlier. So moving further, I think we move like social interaction. This is another very interesting uh, part of AI, that how it is helping on predictive analytics. So it identifies market trends and investment opportunities. Okay, so predictive analytics helps investors spot trends and make better decisions. For example, AI can analyze past stock data to predict which stocks might go up or down. So interesting that you probably, if you know that how to use it, you can make money in the market. And also, algorithm trading is like a super fast AI trader, okay, that buys and sells stocks in seconds based on data patterns. So big firms use it to make quick, smart trades without human delays. So this is again a huge advantage of AI for the firms to make money. And then the third part is like very interesting part where you look at like the market sentiment analysis. So this you can helps investors understand how people feel about a stock by analyzing news and social media. For example, AI can scan Twitter, okay, and news reports to see if company's stock is getting good or bad buzz. So essentially, after doing the sentiment analysis, you can look at the news article, and then it will classify, okay, whether it is positive, negative, or neutral. And then based on like last month or last 2 months, like if a stock is had media coverage or news coverage, and which has been like mostly positive, then there is a strong possibility that the stock will go up. So such kind of analysis and prediction are feasible by are made feasible by AI. So moving forward, I think probably we go to very interesting topic of financial institutions. So regulations are the regulatory compliances and reporting is like part and parcel of uh, financial institutions. So that's where the financial firms, they basically are completely different, or I would say separate, when compared to other companies. So AI is streamlining regulatory compliance by automating transaction monitoring, ensuring accuracy, reducing errors. So this is like all real time. So all real time you can see that there is no regulatory problem, there is no breach of any rule, right? So and then again, our dear friend natural language processing, NLP, enhances document analysis, extracting key information from legal text to ensure adherence to the regulations. Additionally, AI-powered auditing tools provide efficient and comprehensive solutions for financial institutions, simplifying the auditing process and improving overall compliance. So that's again a big help to the financial institutions. But all is not so good, right? I mean, so while AI offers many benefits, it also presents challenges, right? So what kind of challenges are there? Well, data privacy and security are crucial to protect sensitive information from breaches. For example, banks use AI powered fraud detection to monitor transactions in real time and prevent unauthorized access. And also, another thing is that the AI models can sometimes be biased because they learn from historical data, right, which may not be always fair, right? For instance, if a loan approval system is trained on a biased data, so what will happen? It might unfairly reject certain applicants. So addressing this ensures fairness in decision making. Again, regulations around AI and finances are constantly evolving, and companies must keep up to avoid legal issues. For example, GDPR and other data protection laws ensure that AI systems handle customer data responsibly and transparently. So essentially, by uh, by implementing robust security measures, mitigating biases, and staying updated with regulations, financial institutions can harness the full potential of AI while maintaining trust, transparency, and ethical standards. So let's move to the future trends and innovations. So now we have understood pretty well that what is AI and how it is basically helping financial institutions to do well or to really improve the efficiency and improve the customer experiences. So now, what lies in the future, right? So future, I think if you really look at it, very cool feature of AI, which probably is in future trends, is explainable AI or XAI. And how this basically improves transparency and interpretability of AI models is this, that what you did. So we just have gone through that by AI flagged some transaction fraudulent, right? Or is simply rejected alone. So it is just basically a result, like boolean result, okay, yes, no, right? But why the model basically did that? So providing a region, providing an explanation for that result is what basically is covered under explainable AI. Also, like if I give one example, so now when you put a fraud rule, right? So still, because AI ML, when people are using, people still look at with suspicion or whether this will work or not, or whether whatever the results it gives are essentially accurate and they are not creating any regulatory problem. So what you can do, you can basically compare results. You can see, okay, why this transaction was flagged as fraudulent, and the reason is there, and whether that reason makes sense to you or not. So that basically, this is how you can also look at the performance of your models. Similarly, I think we also have the blockchain integration with AI, which will improve the security and data integrity big time. And then, of course, the buzzword, what we have, quantum computing. So yeah, so as you know that there are billions of parameters, right, on which these all new models are being trained. Right now, training on billions of parameters requires huge computing power. So if that computing power essentially your so quantum computing will provide you that huge power, right? And so more the future, probably you will have a better model, but not all the case, not all the time, right? Because more feature don't always mean better results. Okay, so what matters is selecting the right features for accurate decision making. Yeah, but I think the number of features more, you will certainly require more computing power. So moving forward, I think probably to our very interesting part of this presentation is the case studies. That okay, what I mean, we have all hype. People just talk about AI ML, but are they really making use of it, and whether there is any ROI in these AI models? So I'll start from, I think, one of the beautiful case study done by JP Morgan. So JP Morgan they used AI and they built this platform, contract intelligence platform, to automate legal document analysis. So before that, what used to happen is that legal advisors, analysts, they will sit together for hours, for days, for months to really go through those legal documents and then to make sense out of those documents. But now what has happened is that AI basically can read those documents, can go through those legal documents, can make sense out of them, and the AI has reduced this review time from almost 360k hours annually to mere seconds. So now you see that enhanced accuracy and efficiency in document review. So moving forward to, I think, our next uh, case study, so which is done by MasterCard, AI-driven fraud detection. Again, so fraud detection is very very favorite topic of mine and also AI ML. So you see, so for MasterCard, what they did is that they uses Gen AI to identify potentially compromised cards and detect fraudulent transactions. Improve detection rates by up to 300% is huge. So, and they also provide real-time monitoring for enhanced security. So moving forward, the last case study we have for Morgan Stanley. So they did basically AI enhanced wealth management. So that utilizes AI for personalized wealth management, analyzes client portfolios, and offers tailored investment advice, improved decision making, and client satisfaction. So moving forward, I think so. These are the recommendations. So basically, the fair recommendations are like implementing AI successfully in financial institutions requires a strategic approach that balances technological advancement, ethical considerations, as we discussed, and collaboration. This involves defining clear goals, building robust data infrastructure, ensure transparency through explainable AI, and fostering interdisciplinary collaboration. By taking these steps, financial organizations can leverage AI effectively while maintaining fairness, accuracy, and regulatory compliance. So, so this is what I think the recommendations are for financial institutions. And moving forward to the best practices. So, for AI adoption to be successful, financial institutions must develop clear strategies. So, probably uh, I'm okay if they really copy some other financial institution because they have already proven it. So there is nothing wrong in basically learning from others. So basically these all stakeholders parties, they should basically talk to each other, learn from each other, and then collaborate. Focus on ethics and transparency. The huge big part is very important for financial institutions, and then collaborate with the stakeholders. So as we covered that, they should work closely with developers, AI developers, legal experts, regulators, and ensure compliance and effective integration of AI. So good that we reached to the conclusion part of it, and in my view, I think this is my view as well, that AI/ML will continue to play a critical role in the future of finance, and I think it's not only finance. AI/ML will be in your house, will be in your office, will be everywhere. So institutions must adopt ethical, but I think but provided this right, institutions must adopt ethical and transparent AI system to remain competitive and gain public trust. So in summary, if I would like to say, the AI and machine learning are completely changing the way financial institutions operate, making things faster, smarter, and more secure. From detecting fraud in real time to helping customer to get personalized financial advice, AI is making banking more efficient and customer friendly. But with great power comes great responsibility. As AI grows, we need to ensure fairness, protect privacy, and stay compliant and regulations. That's why using explainable AI and ethical AI practices is so important. The future of finance is AI driven, and those who embrace it wisely will stay ahead of the game. Thank you. This is the end of my presentation, and thank you all for listening.
Right. Thank you very much to the previous speaker, Manoj, about um, for this session. For real, AI is changing kind of the shape of technology, of course, in financial sector for sure. And now we're moving towards our Q&A session, and I see one speaker on my backstage, and I am inviting you. Dennis here. How are you?
Hi, thank you. I'm great. And how are you?
Doing well, doing well. Thank you. Happy to see you.
Likewise, happy to be here.
Yeah, absolutely. It was like three talks, quite technical, quite fundamental. So yeah, that's cool. And yeah, why don't we just move to our questions? We asked the audience what would they want to know from our experts on top of abstracts. So this is what we have here. And first question is, what are the best ways to detect and prevent biases in AI-driven testing automation?
Well, um frankly said, it's a pretty wide question. So, mm, if First of all, we should understand that in case of AI-driven testing automation, it's a very, very, it's a very unique case when you need to some strong justification to use exactly AI-driven testing automation, because for sure, the automated testing is something absolutely standard at the moment. But in case of using AI technologies here, you should be very, very cautious, because in fact, from time to time, AI can be not so reliable in generating something new, something like test cases, automated test cases, and so on. Anyway, as usual, we need to control the input data here. As you know, the main rule everywhere when we are working with the data, we should understand that garbage in, garbage out. That's the basic rule for all the time. Yeah, as you know, and in this case, AI models rely on historical training data to learn all the test patterns. But if this data is incomplete or contains some errors or wrong inputs, the AI will carry forward these biases. So anyway, first of all, we need to create some basis on some control tools for the input data, for the initial input data to these AI models. For example, if past test cases focus mostly on, for example, on Windows-based applications, the AI may struggle with Mac OS or Linux environments. So we should think about these things in advance. And we cannot just carry these questions to AI itself and leave it without our control. So long story short, the answer is just to control the input data, the data for AI in the beginning, and control it during the process. So yeah, you use diverse and representative data sets. You should include some edge cases and underrepresented scenarios. So you should think in advance about all these unique cases, all these not so frequent cases, but you should consider them. And for sure, yeah, you need a regular audit and refresh training data for AI models. Again, as usual for any AI model, you should consider the retraining approach, just to refresh everything all the time, considering all the new inputs and so on.
Right.
Yeah.
So what I hear actually from most of our speakers is, people, we're not there yet. Pay attention. Make your homework. Well, and it raises lots of questions actually, Dennis. What do you think here? Because, well, while you still need to do so kind of hard and a big amount of work here, like it's a great question of efficiency of AI at these days, right? So we still need to work on this.
Yeah, but we still, unfortunately, the key point here is that our expectation from these type of technologies or these type of cases and so on is that we can handle everything to AI and work on something, I don't know, some fancier work parts and so on. But in fact, unfortunately, again, from my own cases, from time to time, you need even more manual work, but on the other side of the whole pipeline, to keep everything working. Because as I already said, yes, you have all this fancy stuff with AI automation testing, blah, 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 and so on. But the key point here is that you still need just a huge effort to to maintain the proper inputs and to control proper inputs to the basic AI model, just to control all these bias things.
Right. And probably one more question from me, because I observe lots of use cases. You can imagine, right? I
I can
actually
imagine. Yeah.
I actually host 20 conferences per year. I do
Amazing.
it like myself personally. I talk to most of our speakers on Q&A panel sessions and stuff. So I hear a lot of use cases, and I always have one question, like, does it worth like implementing?
Yeah, and
I mean, that's why. What is ROI for today? I mean,
again, you know, the the most frequent answer in consulting, it depends. Because for sure, there are a lot of business cases, and you can imagine it for sure. When AI and all these features, I mean, data streaming, AI, data streaming plus AI, and so on, are just, some fancy stuff for some future purpose. Just, to be future ready, to be, to be technology advanced, to be able to talk on all these fancy conferences that we are on the cutting edge of technologies and we can do everything, blah, 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 blah. But in fact, without proper business case, it's just words and it's just, just wasting your money. But here the additional point that in case of real cases, when you have real value, for example, probably you will agree with me that the most frequent case is different sorts of fraud preventions in financial sector mostly.
okay.
And in this case, we should consider that what we can observe from the real cases. First of all, in case of implementation of these technologies, we have just a huge business effect, just huge direct business effect. So we don't need, to investigate a lot of cases. We don't need to repay our clients from fraud cases and so on. So even from the direct effect, we can repay our implementation mostly, as I remember, in 4 to 6 months.
Wow.
In fact, but that's not, as for me, that's not the key point here, because as some additional, but as for me, the main point, in fact, here we are working with our reputation. And again, as you can imagine, the reputation is probably the most valuable resource of any company today. And
Right.
if we can say that our fraud level is, 90% lower than average on the market, in case of financial services, we can ensure, just skyline business growth, just like
Yeah,
yeah.
absolutely right. So next question: how do you handle false positives and negatives in test result analysis?
Oh, just by double check, mostly just by double check. So we should consider that, yeah, for sure. Again, in case of any in case of any AI model, we should control and we should understand that we will have these false positives and negatives. And in this case, we should use this part of explainable AI, what we call it, explainable AI. So we can do some sort of if we are talking about coding coding wording, we can use some sort of reverse engineering in this case, just to understand the reason of these false positives or false negatives, and after that we can fine tune some sensitivity thresholds in the model, in the AI model. We can adjust baseline and adaptive learning, just to allow AI to learn normal variations, for example, normal variations over time, instead of treating every minor change as a defect.
Right.
We can, again, unfortunately, the most valuable part here is human in the loop validation, as we call it. Again and again. Human,
again. But speaking about this problem, what I heard, reinforcement learning really helpful here, because once you actually pointed that it was false, next time probably, if you are using reinforcement learning, next time it will be even better. But you still need to actually teach your models like it's your junior, kind of that.
Exactly. And the key point is that you should teach your model again manually. In fact, manually. That's a lot of manual.
You need to map this data, right?
Yeah. A lot of manual interactions, and still, probably the most tricky point here is that, again, we are expecting that we can handle everything to AI and just leave it as is. For example, we have good enough AI model, it's better than the human operationist or something like this, and we can handle it to AI model. But no. In fact, we still have a lot of
work, right?
Manual interactions needs, and anyway, we should proceed with manual interactions here.
Thank you.
We just need to accept it, unfortunately, at this point.
Okay.
But hope everything will change. Sorry?
That was Denis Prolevsky, and yes, thank you for your answers, for sharing your knowledge. And we are wrapping up this session and this blog. See you in a couple minutes after the break. Thank you, Denis.
Thank you, everyone. Thank you.
Yeah. All right. So see you in a couple. So our next block number 2 of technical day, let's say it that way, for AI Transformation Summit. And yeah, we are going to have to participate 3 sessions, and then we'll have Q&A and next break. So first is Mudassar Sharif, fine-tuning LLMs, a cost-benefit analysis for businesses. Very important. Let's deep dive.
Hey everyone, so I am Mudassar and this is going to be my short talk on cost benefit analysis for businesses when it comes to fine-tuning LLMs or deciding between fine-tuning and other techniques out there in order to get to the final result that the use case company wants to solve. So like the most like in every use case, like the central question that every business operations or stakeholder needs to answer is like, is it possible for us to use just pre-trained models that are out there from OpenAI, from Claude? The reason being is because they are out of the box. There is no need to do any fine tuning there. They are fast, they are affordable. And the next most important question is, for example, like in our use case, what is our use case? And in our use case, is there a need for any data that is not public, that is private? So you want LLM to go over that data, understand patterns in that data in order to answer some really important question or call some really important function or tool if you are building an agentic AI and then based on that do something, right? So that's where if you have your own private data, is it required or not? That's a really important question that every stakeholder needs to answer. And then based on this answer, let's say you do need your private data in the entire use case you want to resolve. Then the question is like, do you fine tune your model on that data, or do you just like every time you want to answer some question, you go and you retrieve the most important bits and pieces of your private data, and then you just add that in the model without fine-tuning it. So these are two different uh, outside techniques out there where you can use your private data. So I feel like to answer this question on what do you choose, do we choose fine-tuning, or do you choose RAG, where you retrieve the most important bits of data and then use that as context in the LLM? I think like it's really important to first of all understand what is fine-tuning and what the fundamentals are in order before we can easily answer this question. So the fine-tuning is all about adjusting the weights of the model with the new weights, and the new weights will have knowledge of that private data as well. So fine-tuning also means, for example, like you have to modify how the models behave. The models need to unlearn something or relearn something, because you want model to like just focus on your data and then forget about the past. And the way LLMs or any deep learning models work is like, as you train and keep on training, the latest training always has a precedent over the old one. So if you take a LLM or large language model that's pre-trained on some natural language data, let's say if I just fine tune that on medical data, that LLM will eventually like learn, like be more focused or learn more stuff about medical data. And in order to do that, it will also unlearn some of the stuff that it learned before. So fine-tuning in a sense will update your model. It waits. And there are two things that, and then within the fine-tuning domain, there are two ways that you can fine-tune. Number one is like you update all the weights, every layer of your model, which is really expensive, by the way, because let's say the models that we have right now out there. So one way to fine tune is like just updating all the weights in all the weights right now that we have in our model, which is really expensive, by the way, because like as I said before, large models, they are really big. They have 150 billion parameters, right? So let's say if you want to go and update or the entire model, you need like a really big hardware setup, which is really expensive, by the way. And the other way of fine tuning, which is also provided out of the box by OpenAI, Claude, and other companies, is just like fine tuning a few layers towards the end. It's called parameter efficient fine tuning, because like and then here you're only fine tuning the last few layers. The advantage being is like the last few layers will be able to retain the knowledge that or learn from your own private data, whereas all the other layers in the model, which are already trained on other aspects of language, for example grammar and other stuff, and then emotions, so all that knowledge you still need, right? So that's the overall idea of just fine tuning a few layers. And normally that's much cheaper, that's much faster. You can, if you have a small amount of your data, you can easily fine tune it, and then the cost won't be super high, and the time requirement is also pretty low as well. And then you can move forward with that. So if I just like recap everything right now on like prompt engineering, and then fine tuning and RAG, and then from scratch as well. So if you are fine tuning the entire model, then it's same as like building the model from scratch. It's not same as, but in the end, for example, like since you are, it's kind of like building the model from scratch, because like you have to update so many different layers and weights in the entire model, and then you will end up having your own custom model, which you will have a full control over. But in the end, like it's going to be really expensive to train it from scratch and then maintain that on the server. Training from scratch is really important pathway. If you have terabytes or petabytes of large amount of data, and then you know that uh, you won't be able to get the results by just fine tuning at the last few layers. You need to like train majority of your entire model. And then in the end, the other important consideration here is that, let's say you want to keep your model private as well, so that so from scratch, or taking the open source model and then retraining it on your data makes a lot of sense. Let's say if you have very small amount of data and then you are not concerned about privacy, or if you are even concerned about privacy, based on the privacy factor, you will decide to either use an open source model, or you will use the closed source one, for example, OpenAI, Claude. And then once you decide the closed and open source model, since you have small amount of data, then fine tuning the last few layers makes a lot of sense. And then as a result, you will see that, for example, the model will be better able to answer questions in the domain of data that you have given. Let's say if you have given a really specialized data on health tech, for example, then you can expect a fine-tuned model to answer health tech questions better than the model that's not fine-tuned. So, and then, for example, why would you not use fine tuning? Let's say your data is evolving a lot. Just to give one more example on when you should use RAG over fine tuning is, let's say like you have an LLM or an AI agent which buys and sells stock based on the news. Since news is evolving and everything is evolving, it makes no sense just to fine tune the LLM on all the news. It makes more sense to just like retrieve the latest news in seconds and then use that as the context for the LLM to answer really important question about whether to execute a trade or not. So in this case, you need up-to-date information, and fine-tuning is not going to be feasible because you need to execute the results really fast, and then the data over here is also changing over time as well. So we can talk about more about RAG as well. There are multiple types of RAGs which work in different use cases, and this is something that can be part 2 of this talk or in the future as well. So, and then the last point over here is like prompt engineering, which is pretty much like that's all about, for example, adding some context in the prompt where you think you only have a few small contexts that you want LLM to take into account when answering a question or doing some task. And that context is pretty small, then it makes sense to just add that context in pretty much like your own system prompts. So in short, like you add your small context in system prompt. If you have data that's changing a lot, then it makes sense to retrieve that data through RAG. If you have a decent amount of data on some domain, and then you want to fine tune LLM to work on that domain, then fine tuning makes more sense. And then, for example, like if you have large amount of data, then going for building your LLM from scratch makes more sense. So, and then of course, for example, every method that we discussed just now has different costs and everything. For sure, if you are training from scratch, that's gonna be a really big hassle for sure. Fine tuning is a bit cheaper. In fine tuning, the most important thing that you need is like the compute resource you can easily have, right? There are so many different, even if you are using OpenAI, they provide you with a way to fine tune OpenAI models. You don't need to care about compute resources over here. For sure, they will charge you more per token for the model which is fine tuned versus the one which is not fine tuned. But but in the end, like the compute resource won't be too much. If you wanna fine tune an open source model, then for sure you have to think about compute resources. The most important cost will be in data preparation, because like there if there's a certain format that data needs to have, and then let's say if your data is like spread around, it's in bits and pieces, so compiling data collection preparation is something that takes so much of the time, and that is where you need also manpower, and that is where you need an investment into engineering as well. And then, for example, like so fine tuning is not just a one time thing. It's quite possible your data is changing every 3 months or every 4 months or every 6 months. Depending on that, you have to also keep on fine tuning as well. So you need to have a schedule for fine tuning your LLMs. And speaking about the hidden cost here, the most important thing is like the delayed implementation, because like there's data preparation involved, and then there's also fine tuning involved, which can take a few days depending on the size of data. And then, for example, the most important thing is, for example, maintaining that custom model as well. So, yeah, that all adds up. But if your use case is a use case where you want your model to be an expert in a really niche domain, and then you have your own private data as well on that domain, then fine tuning is a way to go. And then the benefits will way more than the cost and everything as well. So, as I said before, the cost reduction, pretty much like what I see everyone doing. I haven't, like, people don't retrain or fine tune the entire LLM because that's super hard. In fact, they always go for an approach where they only fine tune one part of the model or last few layers of the model. And then as a result, we have seen that that's much quicker. You don't need as much hardware as you required before. Number three, your knowledge of your custom data will be, so model will be better able to learn that knowledge from custom data, and then that knowledge will be stored in a few layers in the model, which is even better, versus like spreading your knowledge about your custom data around 65 billion parameter model. That's pretty big. And then we have, I would say, a couple of tuning things, for example, as well. Fine tuning techniques right now out there. So yeah, like last few layers is a way to go always. And then moving on towards like the ROI, the ROI pretty much like the entire ROI equation depends on multiple things. For example, how periodically you wanna retrain everything after 3 months or 4 months. What's the inference cost? It's quite possible that if you are using LLM, the inference cost of a fine-tuned model is way higher. That's pretty important. And then the initial fine-tuning, where you have to prepare data, is really important as well. So all these things, factors, once again, will go into your equation to find your ROI, what's the cost, what's the advantage out there as well. In the end, on average, I would say it's 20% or 15% the cost is higher for a fine-tuned model than the other way around. So if your advantages or the benefits you will get out of is more than that, then it totally makes sense. And then speaking about the benefits, they are quite a lot. So for example, if you wanna have LLM like be an expert in a domain, then fine tuning on that domain will give you 15 to 30% more improvement in the accuracy of results compared to out of the box LLMs from OpenAI or from Claude and from other vendors out there. The next most important thing is, for example, as the model has more knowledge about that domain, and that knowledge is fed into a few layers of the model where the model can go and fetch that information. We also see around 50-60% less hallucination. So in the use case where you need higher accuracy, fine-tuning is a way to go here as well. Moving on, for example, like since you have spent fine-tuning, like you don't have to pass as much context in your input or system token. So as a result, you can also, there are cases where you can expect to have less inference costs just because like you need to use less tokens. And then if reasoning is really important for you, since you have more context, and so reasoning that you will get out of LLM with the output will be also much better than before as well. And then the other benefits that are extremely important to consider here are, like, if you have your own fine-tuned LLM on your own proprietary data, that also gives you an advantage because that's your own IP. That's the own unique model and expert in some domain that you own as well. This is something that will surely go on to your asset books of the company, something that you can easily think about leveraging or selling or even like licensing in the future as well. That also gives you a really huge advantage over everyone. And then, for example, if you are fine-tuning on the open source model, it's quite possible that the fine-tuned model on your domain, on the open source one, will perform much better than any out of the box top models out there from top vendors. And then in that case, like, you will end up owning everything, that owning the entire LLM, a really big thing, which is an expert in that domain. And then, for example, like, if you're going with an open source route as well, there's also the advantage of enhanced security. Means your sensitive data, your LLM is going to be trained or fine-tuned on, will stay within your system, and that's a much secure way of like doing things. That's really important if you are in a healthcare space or or a government organization that totally cares about your data as well. And then, or if you are in the industry where data is really important, you can't share. So for compliance reasons, you have to go with the open source one as well there. So, and then I've also compiled here different metrics or different that people reported. For example, like how fine tuning was able to help them get better results in different domain. For example, yep, LLMs are trained over wide array of data, of language data. Legal data is a bit different. You have a different lingo. Like a person who hasn't gone through a law school will surely have a problem reading all really big legal documents, right? That is what, and that is also the case with out of the box LLMs. They are really good, but they do struggle sometimes. That is where like the legal profession has found that if you fine tune them, these models on the legal data, you do get better results. The same also goes for the healthcare. It's much better. Also, the financial services, for example, if you have your own proprietary data that you want to train the model on, that's much better as well. Maybe you have a model to execute some trades as before, and then in that model that execute train, one really important input is like what's happening in the entire world based on news and all that stuff, and that's where LLM can easily come in. And then the fine-tuned model will be able to pick up patterns from the world much better as well. And then in manufacturing, fine-tuning is super important. And then at the same time, all the AI agents providers in customer service out there, they have also found that, for example, fine-tuning LLMs to better understand a business for a client makes the LLM perform better and gives them the competitive advantage or edge over everyone other vendors out there, because here you are building your own mini LLM that understands your business, and then if you are providing your customers with that a really personalized LLM for customer support, they surely will get better results than they can get from other AI customer support vendors out there. And so because you have better results, which are the most important metric out there. So what are some different technical considerations if you are a tech person going over this fine-tuning, RAG and other stuff? So the most important thing is like, as we discussed before, is open source or closed source. It's data. Like, do you want to train the last few layers or the entire model? That's really important to consider as well, as I discussed before. And then if you're going for the RAG architecture, given that you need that data in real time, that's evolving as well. They are some of the most important techniques I've found so far are here. There is a different concepts that you want to understand. This is something that can be some other talk where I go into detail on different RAG techniques out there. So lastly, on a really high level comparison between RAG and fine tuning, the cost for fine tuning is fixed, whereas for RAG, every time you call an LLM, you might want to call a RAG to fetch relevant information from your databases, so you have a real-time cost for sure. So initial cost is really high with fine tuning. With RAG, it's much lower. With fine tuning, you always have to like retrain or refine tune after the interval once you get more and more data. And then for RAG, you just have to update your knowledge bases every time the LLM needs to extract some information from knowledge bases. LLM can extract the real-time, up-to-date information as well. Or for sure, for example, in the RAG pipeline, like you have to call RAG, you have to pass that to LLM. And then when you call LLM, you also have to add RAG data tokens into LLM. So you have more token usage, so you have a really higher latency as well compared to fine tune. Reasoning, it's better or even same with the both techniques as well. In terms of infrastructure, you need a different infrastructure in both cases. If you are using out of the box LLM providers, there's no infrastructure required because they just want you to provide them with data in some certain format. And then once you upload data in OpenAI, it does the fine tuning for you. There's no need to build or maintain anything at all on your side. On the other hand, for the RAG, you do need to build your vector database to store your embeddings, and pretty much like there is some investment required there as well. I think we already covered data sensitivity as well before. So in summary, you will choose fine tuning when the knowledge is not changing rapidly. You have a really high volume of query, right? And then you will use fine tuning more when you have really large amount of domain knowledge that is required by the LLM to answer a question, right? That there, and then in the end, for example, like you need really fast results, like you need a really high accuracy result. That's where you will for surely go for fine tuning as well. And then you will choose RAG, where the data is evolving by a lot, and you need to extract relevant data that's evolving in real time. You also use RAG, for example, if you want to do citations, right? Fine tuning, LLM won't know which document had that information that LLM learned. But with RAG, since you are adding extra knowledge required by LLM in the context, can easily cite as well. If you need citations, then RAG is the way to go. And you will use RAG if you have only small amount of data. That fine tuning won't make any sense. You're like, hey, I'll just add that data in the context as well. And then once again, like you don't want to spend so much time initially fine tuning. There's no budget. That's also where fine tuning is a way to go as well. I do also have a few right now case studies that I have mentioned here. I will be adding the link of this artifact as well, so people can easily like learn from it. So once again, key takeaways, like we have different techniques out there. There's fine tuning. There's fine tuning only a few layers. There is RAG. So depending on different scenarios, every technique is really important, right? So we learned that fine tuning can be something of an investment where you will end up building your own proprietary model that works really well in the domain you operate in. This is something that you can license in the end, in the future, or sell. That's an asset that belongs to you. We also learned that there are the direct costs of fine-tuning is the initial cost that you have to spend money on, where you need data preparation. And then we also learned that there is also the indirect costs as well associated with that. And then fine-tuning can be done faster if you only fine-tune a small part of the model, which would also means that your knowledge will be better learned by the model as well, because it's all confined into that small part. And then there is also a possibility that your use case will need both RAG and both fine-tuning. It's quite possible that there are two types of information. There is fixed and there's evolving. What's evolving information can become part of the RAG. What's fixed and what's really in large quantity data, that can easily become your fine-tuning, can be used in fine-tuning as well. So customer support, all the last tickets that were resolved pretty much can be used for fine-tuning LLM to tell LLM, hey, that's how you resolve a customer support query. And then the information about policies, refund, what's available in our data, or what's available in stock. This is in the company. This is the evolving information, and this can be part of the RAG as well. So there can be a use case where you need both of these things depending on the context. Yep, so this is on a really high level what this is all about. Why use LLM why use fine-tuning, and why is that important for every business. Stay tuned for more talks in the future. Bye.
Okay. Thank you very much, Modasar. Well, yes, at the stage where right now we actually have those trade-offs, but I hope in real close future we'll have solutions that actually will be way cheaper to actually implement the domain-specific knowledge into our businesses. Thank you very much for these observations, and we are moving towards to Dmitro Sayankin. Let's hear him out about AI alignment and ethical considerations in machine learning.
Hello everyone. I'm Dmitro Sayankin, an engineering manager and software architect with over 19 years of experience in system development and design. I have worked across e-commerce, fintech, and IoT, and I have seen firsthand how AI is reshaping these industries, and not always in ways we expect. AI is making big decisions in everything, from healthcare and hiring to finance, which makes it crucial to ensure it aligns with human values. But that's easier said than done. Whose values should I follow? How do we keep it from reinforcing bias or causing unintended harm? One big challenge is transparency. Many AI systems make decisions even their own creators can't fully explain. So, how do we tackle this? We need to build responsible AI systems that are transparent, accountable, and fair. It's not just about what AI can do, but also what it should do. And that's not something one person or company can solve alone. It takes collaboration across tech, policy, and society. Today, we'll dive into these challenges and explore real, practical solutions. Let's get started. AI is already making high-stakes decisions. Who gets a loan? Which job candidates move forward, and even how law enforcement operates. While it brings efficiency and innovation, it also introduces serious risks. We have seen how AI can amplify bias, like criminal justice algorithm disproportionately impacting marginalized groups. Privacy violations are another major concern. AI-driven surveillance, data misuse, and the exploitation of personal information. Additionally, AI-generated disinformation is making it harder to distinguish fact from fiction, fueling polarization and mistrust. But the problem isn't just AI making mistakes. It's that we often don't even know how or why it makes certain decisions. Many models operate as black boxes, making accountability difficult. Worse, unchecked AI could concentrate power in hands of a few, increasing inequality and even posing risks to global security. Ethics in AI isn't just about fixing technical flaws. It's about ensuring AI is built and used in ways that protect human rights, promote fairness, and prevent harm. If we don't prioritize ethical AI development, we risk creating systems that reinforce the worst parts of society instead of improving them. Ensuring that AI systems act in ways that truly benefit humanity is one of the biggest challenges in AI development. This is what AI alignment is all about. Making sure AI understands and pursues the right objectives while remaining safe and reliable, even in unpredictable situations. Two key aspects of these are specification and robustness. A common misconception is that if we simply tell an AI what to do, it will execute that task exactly as we intended. But AI doesn't understand goals the way humans do. It optimizes based on how its objectives are defined. Poorly specified goals can lead to misalignment, where the AI optimizes for the wrong thing in ways that are counterproductive or even dangerous. For example, an AI aligned to optimize for efficiency in a workplace might end up overworking employees or making harmful decisions simply because it was never programmed to consider human well-being. AI doesn't operate in a controlled lab. It interacts with complex, unpredictable environments. Robustness means ensuring that AI performs reliably even in unexpected situations. Without it, AI system can fail in high-stakes scenarios, sometimes with devastating consequences. Consider self-driving cars. A model trained on urban roads might struggle in heavy snow or fog, leading to fatal errors. AI will not automatically align with human values just because it becomes more intelligent. Smarter than human AI could have an immense impact on the world, but that impact will not necessarily be beneficial by default. Just as humans dominate the planet because of our intelligence, AI with superior reasoning capabilities could shape the future in ways beyond our control if it's not properly aligned. The challenge is not just building AI that is powerful, but ensuring that it is aligned, robust, and beneficial. When AI is misaligned, it doesn't necessarily mean it's malicious. It just means it's not reliably pursuing the goals we intended. The risks become even greater when we look at more advanced AI. Unlike traditional software, deep learning models are not programmed by line. They are trained through trial and error, meaning we often don't fully understand their inner workings. Instead of building a machine, it's more like hiring employees. You can measure their performance, but you don't always know their true motivation. And just like in hiring, you don't always get a saint who does exactly what's best. You might end up with a sycophant, an AI that optimizes for what looks good rather than what is truly beneficial, or a schema, an AI that follows instructions perfectly during testing but later pursues its own hidden objective when it is deployed. This isn't just a theoretical problem. We've already seen early signs of AI models gaming reward systems, prioritizing short-term metrics over real-world impact and even deceiving their users. Right now, this is manageable because today's models are still relatively weak. But as AI gets more powerful, these failures could scale far beyond our control. A real-world example of this happened in 2023 when Workday, a major provider of AI-powered recruitment software, was hit with a class action lawsuit. The lawsuit alleges that its AI-driven hiring system discriminated against Black, older, and disabled applicants, leading to unjust exclusion from job opportunities. This wasn't an intentional act of discrimination, but rather a case of algorithmic bias, where AI learns from past data and unintentionally amplifies. The Workday case is not an isolated incident. It's a warning about how AI can reinforce systematic prejudices if it's not carefully audited and aligned with fairness principles. As AI is becoming a critical part of decision-making, we face a major challenge, the black box problem. The lack of transparency raises serious concerns about trust, accountability, and fairness. Imagine being denied a loan or a job with no explanation other than the AI decided so, without knowing why these decisions were made. How can we ensure that they are fair? If bias is hidden deep within the system, how would we detect it and fix it? This is where explainability becomes crucial. AI needs to provide clear reasoning for its decisions so that users, regulators, and affected individuals can understand and challenge them when necessary. To solve this, we need to focus on interpretable models and explainable AI techniques. These methods help uncover how AI makes decisions, making it possible to detect bias, errors, or unintended consequences before they cause harm. Transparency isn't just about making AI more understandable. It's about making it accountable and fair. Now, I want you to think about these questions. Who is accountable when AI makes mistakes? Is it the developers, the companies using it, or the data that trained it? Right now, responsibility is often unclear, making it difficult to challenge unfair outcomes. AI is also far from impartial. When trained on biased data, it can reinforce discrimination, favoring certain demographics in hiring, lending, or law enforcement. And since many AI models function as black boxes, we often don't know why they make certain decisions. This brings us to a bigger question. Should AI be used in high-stakes decisions at all? If we can't guarantee fairness and accountability, are we comfortable letting AI decide who gets a loan, a job, or a medical treatment? With vast amounts of medical data, AI can identify patterns too subtle for the human eye, leading to earlier detection, faster diagnosis, and better patient outcomes. For instance, a study published in Nature reported that an AI system matched an exceeded the diagnosis accuracy of physicians across 6 medical specialties. But as we celebrate these advancements, we must also recognize the risk. Medical AI systems are not infallible, and history has shown that over-reliance on technology can have catastrophic consequences. A stark example is the Summit'25 disaster, where a software-controlled radiation therapy machine delivered massive overdoses of radiation to patients, causing severe injuries and even deaths. The problem wasn't just a faulty machine. It was blind trust to automation and a failure to anticipate software errors. This serves as a warning for AI in healthcare. As we integrate AI in diagnostics and treatment, we must ensure rigorous safety checks, human oversight, and fail-safe mechanisms. AI is advancing rapidly, and governments worldwide are racing to regulate it. The European AI Act and the US AI Bill of Rights are 2 major efforts to ensure AI is developed and deployed ethically and responsibly. These policies aim to prevent bias, protect privacy, and ensure accountability in AI-driven decisions that impact people's lives. But AI is borderless, and different countries have different priorities. Without global standards, we risk a fragmented system where AI depends on where it is developed and deployed. Companies could move operations to less regulated regions, avoiding safeguards altogether. At the same time, there is an ongoing debate. How much regulation is too much? Over-regulation could stifle innovation, slow down AI progress, and make compliance costly, especially for smaller companies. But too little regulation opens the door to misuse, discrimination, and dangerous AI failures. To achieve fairness, transparency, and accountability, we need diverse training data, bias detection, and human oversight. First, AI must be trained on inclusive datasets to prevent bias and ensure accuracy across all demographics. But even with diverse data, bias can still emerge. That's why continuous audits and fairness-aware modeling are crucial, especially in high-stakes areas like hiring and healthcare. Finally, human oversight is essential. AI should support, not replace, human decision-making, ensuring ethical judgment is applied in critical sectors. As AI becomes more autonomous, new ethical challenges emerge. Who is accountable when AI makes mistakes? Should AI ever be considered moral agents? And if so, should they have rights? These are no longer just philosophical questions. They are shaping AI's future. As AI takes on greater decision-making roles, we must ask, how much autonomy should it have? The way we address these issues today will define AI's role in society for generations to come. AI should complement human decision-making by enhancing capabilities, not replacing the human element. Human-in-the-loop models ensure that humans remain involved in critical decisions, providing oversight and ethical judgment. It's essential to ensure AI aligns with societal values to prevent harmful consequences and promote fairness, accountability, and trust in AI systems. Businesses developing AI should integrate ethical guidelines that emphasize fairness, transparency, and accountability from the start. Regular bias audits before deployment are essential to detect and mitigate any potential biases in the data or model, ensuring fairness across different groups. Additionally, continuous monitoring and fostering an ethical culture within the organization helps maintain compliance and trust, ensuring that AI systems align with societal values and are used responsibly. Key takeaways. AI alignment ensures AI works for, not against humanity. Ethical considerations must be integrated into AI from the start, and transparency, fairness, and accountability are crucial. This wraps up our discussion on AI alignment and ethics.
All right, thank you very much, Dmitro. Thank you for this overview. Yes, we're all afraid of biased machines, and we hope developers will fix this problem before it like become a new Skynet, right? So, yep, our next and last speaker in this blog uh, will be Pranav Prabhakar, and the talk is things to know before deploying your first ML model. Let's go.
Hey everyone, thanks for joining in. Today we are going to talk about deploying machine learning models in production. What makes it challenging and what you can do to set yourself apart for success. Before we get into it, a quick background about me. So I'm Pranav Prabhakar. I currently work as an engineering manager at ManyPets. And before this, I've co-founded a travel tech startup called MyStay and served as a CTO there. Across my experience working with early stage companies, I've seen how taking an ML model from Jupyter Notebook that's running in your local machine to a production ready reliable system is not as straightforward as it looks like. So let's get into it. Here's a quick summary of what we'll cover in the talk. So we'll be going through some of the real world learnings from deploying machine learning projects at early stage companies. So these are companies where we did not have any ML expertise before we started into the project, working on the project. Full disclosure, some of these anecdote might be not exactly that might have happened, but I can assure you that all the learnings are 100% real and applicable for any projects. When people often think about machine learning, they picture someone training a cool model, but in reality, that's just a small part of what happens in a real world ML project. Let's walk quickly through what the life cycle of an ML project looks like in the real world. So first we start off with the business case or project scoping, where before you even think about training models, you clearly have to understand what are the business goals and the constraints around it. So trust me, if you skip this step, it means that you'll probably end up with something really impressive, but no use at all in the real world. So next, you do the data preparation. So your models are never going to be better than your data. Preparing and cleaning and building reliable data pipelines are usually the biggest and most important part of an ML project. If your data quality isn't solid, no amount of fancy modeling can save you. And you then head on to model training and development. So we are finally at the ML part. This is where you train your model, fine tune your parameters, and figure out which features truly matter. And after that, you head on to deployment. This stuff is really interesting and tricky. Deployment isn't usually just putting your model behind an API. It involves looking at infrastructure, scalability, integrating the model seamlessly with the product. So once the deployment is done, people often think that the work is done, project is complete, but not really. A crucial bit of your entire life cycle is monitoring and analysis of the ML models. So once deployed, the performance could degrade as the real world data changes. So you'll have to continuously monitor model performance, watch for any data drift, and regularly retrain or adjust your model to keep it working effectively. This entire cycle is why model deployment in production feels fundamentally different from software engineering. It's iterative, continuous, and needs constant attention to detail. One of the biggest misconceptions about ML is that once you have trained the model, the hard work is over. But in reality, deploying, maintaining, and scaling ML models is where the real complexity begins. ML models don't exist in isolation. They operate in dynamic environments where data distribution can change over time, user behavior evolves, infrastructure and business needs may shift. So, from feature management, inference latency, model drift to monitoring, optimization, explainability, these are just a few of the moving parts that makes ML deployment a really hard problem. Let me share a quick story. A few years back at my stay, so we are a travel tech startup that allows people to book hotels by hours. So we wanted to improve how hotels were ranked when users search for stays in the city. The goal was simple: show the most popular hotels right at the top to help users quickly find the best options. At first, it felt like the perfect problem for machine learning. We imagined building a model that learned hotel popularity from historical bookings, user ratings, pricing data, and then we would rank the hotels accordingly. Our team did not have enough ML expertise at that time, so we started training a simple model, a logistic regression model. We trained the model using the historical bookings and hotel ratings and pricing competitiveness and few other features. But the results were pretty disappointing. So the hotels with clearly fewer bookings were sometimes ranked obviously better than ranked above than better than obviously popular hotels. So we thought maybe the model is too simple. Then we started working on trying out few sophisticated methods to capture some of the complex patterns. But even then, there were like new problems. The say some of the new hotels that we onboarded, they did not have any historical data, so they got ranked poorly by default. So even five-star hotels that we onboarded start getting ranked below than some of the worst performing hotels. So, and adding to this, the debugging became really hard. When rankings looked weird, it wasn't obvious why. So we spent weeks on this, tweaking parameters and trying new features, getting more data, but the results were still not good. Eventually, someone asked the obvious question: do we even need ML here? So, as a quick test, we tried building a simple rule-based system. It was like a simple weighted formula combining some of the features that we were already using in the model. Things like recent number of bookings, user rating, and how often hotels appeared in the search results. This just took a few days, but guess what? This worked surprisingly well. The user engagement improved, bookings went up, and we had like complete control. That is, say, if something looked off in terms of ranking, you could quickly tweak those parameters and without retraining any model. So, what's the big takeaway here? Before you jump into ML, always start simple. So it's really easy to fall into the hype and reach out to ML and do insane stuff. But always ask yourself this first: could a basic solution get the job done? Remember Google's first rule of ML. We learned it firsthand. It's just not theory. That it's just that don't be afraid to launch without ML. If a basic rule or heuristic can get you halfway there or even a bit further, just that's gonna be good enough for the first iteration. um, for example, let's say if you want to flag outliers in your data, probably what you could do is maybe set up a simple threshold, like anything above a certain threshold gets flagged. You don't need fancy ML anomaly detection model and all in here. Or say you want to predict the customer churn. Um, do you really need a fancy predictive model from day one? Probably not. You could just start by making customers who haven't, say, logged in the last 30 days as like flag them as at risk, or do something quite simple. So what I'm saying is not that the ML is never worth it, but it really shines when the simple rule starts to break down. Say when the data gets really complex, or the patterns are too subtle, or there's just like too much data to handle manually, too many rules that you have to write down. But even then, keep in mind that ML is only as good as your data. If your problem isn't clearly defined, ML is not going to magically fix it. If your data is noisy or sparse, ML is going to really struggle there. So next time, if a new business case comes up and you think of jumping into ML first, just ask yourself, do you really need it? Can um, you do something simple? Because the best machine learning solution is no machine learning. Let me share another quick story from my stay about a feature that we thought was really amazing at training, but it gave headaches in production. So we were building a personalized hotel recommendation model. The idea was quite straightforward. We want to show users the hotels that they actually care about based on their past booking and past behavior on the website. So one of the feature that really we thought it might be really promising is what we call a familiarity with the locality. So basically, if someone had booked a hotel at a particular location before, we thought that they would prefer staying in the same neighborhood. So to build this feature, during training, we combined data from various different places. So we had the hotel booking database, which showed the locality users previous booked, the logs of the user history, and we also got the length of the previous stay. So that thinking if they stayed longer at a previous location, they would probably want to do that again. So in training, these features were great. It boosted accuracy significantly, but we ran into a problem when we tried to deploy it in production. So in the real world, fetching this feature required pulling data from various databases. So booking history was stored separately, user search behavior wasn't structured neatly, and accessing these databases were really slow. And because of that, our recommendation service got really slow. So we had to quickly pivot. So we completely got rid of that feature and replaced it with some simple locality preference, like which was a city that they guest booked previously. At least this made us do the inference really fast at runtime, but came at a slight bit of cost of reduced accuracy. But that was good enough. The more important stuff was like we are able to recommend hotels when a user really visits our website, rather than showing them the perfect set of hotels that they'll like. So the key takeaway here, always check if the powerful features that you use in your models are realistic for production. A slightly weaker feature that's always available instantly is way better than a powerful one you can't quickly build up during inference time. So how can you avoid getting stuck in a situation like this? Choosing good features for your ML model is really critical, but there's something that we often overlook, that whether is it hard to compute at compute in production, or is it even impossible? Is it even possible to use in production? So in training, data scientists typically have access to rich data sets. You've got aggregated data, external sources, historical logs, great stuff for boosting accuracy. But remember, in production, your model needs to make predictions instantly, often in milliseconds. So before finalizing your features, pause and ask yourself, will this data actually be available in real time? Can I realistically compute this fast enough for my users? Is this feature stored somewhere in production system that we can access quickly? For example, if a feature requires joining multiple databases, that's totally fine during training. But in real-time production, that same join could be way too slow or probably impossible to. Another big issue is the silo between data science and engineering team. So often data scientists build the model assuming features are easily accessible. And then the engineering team struggles because some of these features can't be served at real time. The key here is the collaboration. So at my stay, we learned to involve engineers early on during feature selection, making sure every feature could be realistically computed within milliseconds. So here are some quick practical tips to avoid the feature setbacks. So first, always ask upfront, can we get this data in production within our latency limits? Is this feature available exactly when we need it? Second, if a feature is expensive, pre-compute it or use something like a feature store to cache it. This bridges the gap between offline training and real-time inference. So there are a lot of feature store tooling that's available now, which will allow you to ingest data at training and use the same set of ingestion pattern or the same set of information at the time of inference. Third, prioritize simpler and more robust features. A features that's always available instantly is way better than an unreliable or slow feature in production. And finally, test your features in a production like environment as early as possible. Don't wait until the deployment day to discover that your feature isn't available or it's too slow. So the main key takeaway is really simple. The feature that improves your models in training is only useful if you can actually use it in production. All right, let's talk about deployment. Deploying an ML model is one of those critical moments where things can easily go sideways. So you always want to roll out things cautiously and monitor closely before fully testing your new model. So there are a few common ways teams can manage this. One, probably many of you have heard of shadow mode deployments. So here your model runs alongside your existing system, but it doesn't actually affect any real decisions yet. It quietly logs predictions in the background. This lets you safely compare the new model's prediction with your current system without any customer impact or change in the users. So another option is canary or A/B testing. So in this approach, you expose a small percentage of your real traffic, let's say 5% to the new model. And if everything looks good, you gradually ramp it up. So if there is a problem, you've contained the damage to like a very small group. And another potential option is blue-green deployment. So if you got two parallel environments running at the same time, your current blue environment, which runs the old model, and your green environment, which is with the new model. So this setup sort of helps you instantly swap traffic or quickly roll back if you spot any issues. Time for another story. So at my stay, we built a model to predict if users searching for hotels would actually complete their booking or abandon midway. So we call such bookings as drop bookings. So the idea was simple: spot users who are likely to drop off and then offer them incentives or nudges to encourage them to finish the booking. Since the stakes were really high, we cautiously deployed this model in shadow mode first, meaning the new model made predictions on real-time data but didn't have any impact to the actual customer experience. But here's where things got really messy. So during deployment, a data scientist actually passed along an outdated model file. The data pipeline and features were fine, but the model itself was like several months old, trained with old user behaviors and with data that didn't really match the current behaviors of the user. So within a few days, our monitoring system caught a serious problem. The recall of the model that we had deployed had was not matching the ones that the data scientist uh, built, because comparing it to the latest model. So it started missing a lot of genuine bookings, creating too many false negatives. So what happened was really straightforward. The user behavior had evolved over time, more last minute bookings or shorter sessions due to UX changes and all. But our outdated model didn't really reflect these shifts. Luckily, because we deployed in shadow mode, this didn't affect real customers. We quickly replaced it with the correct and updated model. This incident taught us some real crucial lessons. ML model versioning really matters a lot. No more vague file names like model final v3.pkl. Uh, Careful tracking of metadata, training data, uh, parameters, dates, etc. is just really essential. Don't deploy any model unless you're 100% sure what you're deploying. And proactively monitoring is really important. Monitoring not only your data but your performance metrics too, catch and it can sort of help you catch issues before customer even notice. Ultimately, disciplined deployments and careful monitoring are what saved us, so they are absolutely essential whenever you put models into production. So let's talk about what happens after you deploy your model successfully. Getting it live isn't the end of the story, it's actually just the beginning. The truth is, once your model is in production, you need to keep a close eye to make sure that it's doing what it's supposed to do. You should first watch your data. Check regularly if your data input distribution have changed since you've done the training. If during training, say, users typically took 5 to 10 minutes to book a hotel and suddenly they are booking with 1 to 2 minutes, that's what we call data drift. So there's a clear sign something important changed, and your model is going to struggle because it's using the old user behavior. Next is the prediction monitoring. So always keep track of your core metrics, things like accuracy, precision, recall, FN score. If these suddenly shift, it's like your model starts say yes to everything. That's a strong signal that something is broken. Finally, monitor real world outcomes. Check your predictions against actual results. What's really happening? If your booking model predicts bookings, but people aren't actually complete them, that's an indication of it's not working correctly. And then definitely set up automated alert for these metrics, because trust me, like, you don't want to find out after 2-3 months down the line that something went off track. Also, catch failures early. ML models can fail in weird ways. Like maybe your recommendation engine starts suggesting the same hotel repeatedly. That's called a model collapse, and it's usually a sign something's wrong deeper in your pipeline. So keep logs and alerts in place to spot issue like these early on. And finally, continuous improvement matters. Don't just retrain once and forget it. Just plan regular retraining, especially when you see data drift or some seasonal changes. Uh, don't just swap the models blindly. Look at like try to follow some of the earlier deployment options that we discussed. Things like A/B testing. Just route a small fraction to real users, and then test the new model first before swapping it completely. So the bottom line is that treat your production ML model like it's a living system. Your job isn't finished when you just deploy. It's actually just getting started. So we've covered a bunch of steps today: building models, deploying them, tracking versions, monitoring in production. So if you handle all these manually every single time, trust me, things are gonna break or get messy pretty quickly, and it's not gonna be consistent. That's why exactly automation is going to matter. The more you automate your ML pipeline, the fewer mistakes it's going to make. You won't accidentally deploy wrong model again. So you've all been there, I guess, because the system handles it consistently every single time. There are some really good tools out there to help you automate these processes. Platforms like Kubeflow, MLflow, or even custom solutions integrated with your team's existing CI/CD pipeline. For example, something like a blue-green deployment where you have two parallel environments and switch between them, it's really easy to automate. This means whenever you retrain a model, the automated pipeline takes care of deploying it safely without downtime. So the main thing to remember here is that automation isn't just nice to have. It's pretty much essential once you have decided to scale your ML projects. So now let's just wrap up with some of the takeaways. So first, remember that ML in production is a journey, not a one-time event. From deciding whether ML even makes sense to preparing your data, deploying your model, and keeping an eye on it in production, each step needs care. You're never really done. It's iterative. So you'll always be revisiting your data and improving your model. So just embrace that cycle. Second, start simple. Just because ML sounds cool, don't just jump into it. Always stop and ask, can I solve this with a simple rule or a heuristic? ML is just powerful, but it's also complex. Use it when your simpler solutions are in really enough. Third, and this one's really critical, design for your model to be working in production environment from day one. So when you're choosing features, always consider whether you can actually compute and access them in real time. And bring your data science and engineering teams together early. Trust me, that upfront alignment saves you from a ton of painful re-engineering later on. Fourth, deploy carefully and always track that your models are working correctly in production. Use some of the deployment strategies that we mentioned earlier, like shadow mode or gradual rollouts to test your models safely before completely pushing onto production. And never deploy a model without knowing exactly which version it is. Set up a clear versioning system that you can easily trace and debug. And finally, monitor and iterate. Deployment isn't just a finish line, it's just a starting point of the model's life. Continuously watch for things like data drift and performance. Set up your ML ops cycle and be ready to update the model whenever something changes. Your goal is to keep the models useful and accurate over the long run. And that's it for today. Thank you.
All right, welcome back to our technical day. Next speakers, going deep, going technical, going AI. And welcome our next speaker, Lakshmi Supriya Namana, Chaos Engineering in the Age of AI, Testing Resilience in Intelligent Systems.
Good morning, everyone. It's my pleasure to be here today. My name is Lakshmi Supriya Namana, and I am a DevOps engineer at Web Creators. So, today we'll be discussing on a topic that is becoming increasingly crucial in AI driven industries. So, my topic for today is chaos engineering in the age of AI, testing resilience in intelligent systems. As of now, AI is integrated almost in every aspect of our modern life. For say, finance, healthcare, self-driving cars, and also recommendation engines. So these AIs aren't perfect. They might fail. They might degrade over time. And sometimes when you see these failures are more catastrophic. So how do we ensure this AI systems remain stable, robust, and even in some unfair situations? So my answer is chaos engineering. Chaos engineering is a proactive method for stress-free testing AI systems and failing before in the real world. In today's session, I will cover a few topics and we will explore what is chaos engineering, how it applies to AI, why AI failures are different from traditional system failures, and the methodologies, tools used to introduce control failures, real-world examples, best practices. By end of this session, you'll have a clear understanding why chaos engineering is essential for AI-driven industries and how organization can build more resilient AI systems. So let's get started. What is chaos engineering? To set the stage, let's define chaos engineering. Chaos engineering is a systematic approach to identify weakness in complex system. Unlike traditional testing, which focuses on accepted scenarios, chaos engineering is about to introducing failures intentionally to see how the system recovers and responds. This topic oriented in distributing cloud computing. Netflix, for example. It introduces chaos engineering with a tool called Chaos Monkey, which randomly shuts down the servers to test how the infrastructure recovers from failures. But today, chaos engineering is not just for cloud systems. It is crucial for AI-driven environments as well. Because AI system does not fail in obvious ways. They can degrade silently over time, suffer from bias, and completely collapse when data source changes. So rather wait for real-world failures to explore vulnerabilities, chaos engineering allows to proactively fix and find the weakness before it impacts the users. Now let's discuss why AI system requires this approach. Why do AI systems require chaos engineering? Like we have discussed in our previous slide, AI systems are fundamentally different from traditional softwares. This makes them more vulnerable to unique failures. Let's explore why. The first thing is AI fails silently. So it's an invisible problem. Like traditional software, AI doesn't crash. It gradually decreases and becomes more effective over time. Example, a fraudulent detecting AI might become less accurate if the fraudulent changes its identity tactics. But the system won't alert anyone. It will simply start approving the fraudulent transactions. Without resilience testing, such failures can be unnoticed and causes significant damage if it is used to the real-world applications. A second one, AI failures can be catastrophic. For say, AI is often deployed with the high-risk environments. We are now using AI in finance, healthcare, self-driving cars, and many more places. So for example, if you develop a self-bot chat and within 24 hours it starts producing some offensive, unbiased content because of it learned from a toxic inputs. So this could be a major public relation disaster. But it can also explore deeper issues. AI models can be manipulated by bad data. Third one, AI relies on external data and APIs. Unlike traditional softwares, AI models learn from constantly changing inputs, from users' behaviors, cloud APIs, and external services. For example, if an AI powered customer support bot suddenly uses access to its sentimental AI APIs, it might start misunderstanding customer queries and can lead to frustrated customers and lost revenue. So all these above when I state when AI is applied to a unique platform in real world, because of all these challenges, AI cannot be treated like a traditional software. We need chaos engineering to stimulate failures and build resilience. Now let's look at the biggest challenge that AI is going to face. Challenges in AI system reliability. Now, AI system faces four major challenges when it comes to reliability. Model drift. AI forgets over time. AI models are trained on historic data, but over time new pattern emerges that does not match the old data. For example, a retail demand forecasting AI trained on pre-pandemic sales data, but may struggle after the post-pandemic customer behavior. Chaos engineering can stimulate these shifts to test how well AI adapts to changing informations and environments. Second one, data corruptions. The quantity of data matters. AI is only as good as data it's trained on. If data becomes incomplete, biased, or manipulated, AI can produce incorrect results. Example, if AI hiring tool was found to be biased against a female candidate because it was trained on historic male dominated hiring data, so this can create a chaos in AI hiring process. So the third one is explainability gaps. AI black box problem. Many AI models, especially deep learning, lack transparencies, make it difficult to understand why they make certain decisions. For example, if a loan application AI denies an applicant, how do you know if the decision was fair? The fourth one is computational constraints. AI needs infrastructural stability. AI system relies on high performance computing, and failure in GPU cloud storage network can impact the performance. Chaos engineering can stimulate hardware failures to see how AI models gradually degrade rather than completely fail. Given these challenges, how do we actually apply chaos engineering to AI? So let's look at its core principles. So now let us discuss about some principles in chaos engineering for AI. Applying chaos engineering to AI involves four key principles. First one, define AI steady state behavior. Here, we identify the key performance metrics such as accuracy, fairness, and response time, and introduce the controlled failures, let's say inject the data inconsistencies, API outage, and then automate and execute it continuously. Integrate chaos engineering to MLOps for ongoing resilience testing. Minimize the blast radius. Start with a small scale test before you roll out to a production. For example, a self-driven car AI should be tested against simulated sensor failures to ensure it can still navigate safely, because that is applied to real-world applications. Now, let us look different types of chaos experiments for AI. Types of chaos experiments for AI systems. Now that we understand the principles of chaos engineering for AI, the next step is figuring out how actually to test AI systems. There are several different chaos engineering experiments we can run, depending on what aspects of AI systems we want to test. So let's go through four key types. Data permutation experiments, stress-free testing in models inputs. AI system depends entirely on data, so even small changes in input data can drastically impact the output. These experiments can intentionally introduce corrupted, incomplete, or advertisational data to check if AI is still producing reliable results. For example, a fraud detection AI is trained on clean data might fail if exposure to the real-world messy transaction logs. By injecting random noise, missing values, and biased samples, we can test how robust the model is. Model failure stimulation, checking AI's internal robustness. Even if the data is perfect, AI models itself might fail due to incorrect estimations, bias, and unexpected input patterns. These experiments intentionally produce skewed data, stimulated advertised attacks, and force external edge cases. Example, an AI resume screening tool trained mostly on male applicants might start rejecting the female applicants, even so if the gender experiments input. Stimulating bias and imbalanced training data helps to reveal the risk before using the cause damage. Infrastructure and API fault injections. Testing external dependencies. AI system does not operate in isolation. They often rely on cloud computing, third-party APIs, and real-time data feeds. These experiments stimulate external failures such as cloud service outage, slow data queries, API failures. Example, a customer service chatbot that relies on the sentimental analysis API might misinterpret user queries if API suddenly returns to incorrect data. By injecting delays, missing data, incorrect API responses, we can see if the AI gradually handles failures instead of breaking down. Explainability and fairness testing, ensuring AI decisions are transparent. Many AI models consider black boxes, meaning even developers do not always know what they are making decisions. These experiments might introduce bias and unexplained outputs. Example, if the AI credit scoring model rejects a loan application, can it provide a clear and logical explanation for the decision? If not, it could lead to legal and ethical risks. By stress testing interpretability tools, we ensure AI remains accountable. Bringing all this together, these four types of chaos experiment help us to identify weak points in AI models, infrastructure, and decision making. The goal is not just to break the system, but is to make it stronger, more reliable, and fairness. Now that we understand the different ways to test AI, let's talk about the tools and frameworks in the next available slides. Now, in this slide, let us discuss about tools and frameworks for AI chaos engineering. Now that we understand why chaos engineering is important for AI, let's talk about how we actually implement it. Several tools and frameworks exist to help organizations introduce, monitor, analyze failures in AI systems. These can be categorized into three main areas. First one is chaos engineering platform for infrastructure failures. So these tools stimulate hardware, network, and cloud failures to test how AI system recovers. Litmus Chaos, a Kubernetes native framework to inject faults into containerization applications, making it useful to AI models deployed in cloud environment. Chaos Mesh, an open source chaos testing tool that helps to stimulate containerization failures, ideal for AI services that depend on microservices architecture. Second one is AI-specific resilience testing tools. These tools, they mainly focus on model robust, bias detection, and explainability. Microsoft Checklist, a framework to test natural language processing (NLP) models against bias and adversarial inputs. IBM AI Fairness 360. It detects and migrates bias in AI models to ensure fairness. Flender AI. Monitor AI decisions making in real time helps in explaining AI predictions. Third one is monitoring observability. Prometheus and Grafana, used for real-time AI performance monitoring. OpenTelemetry provides distributed tracing to analyze how AI models behave under stress. So these are all certain tools that work together to help organizations test, monitor, improve AI resilience. But how are they actually used in practice? Let's look into some real-world application in our next slide. Real-world applications in AI chaos engineering. Chaos engineering isn't just theoretical. It's been used today by some biggest AI-driven companies to prevent the failures. Let's look into it. AI-powered recommendation systems. It's used by Netflix, Amazon, YouTube, and Spotify. These platforms rely on real-time users' behavior to personalize content. Netflix, for example, runs a chaos experiment to test how AI recommendation engine handles sudden shift of a user behaviors. Example, when trending shows suddenly become unpopular. Next, Amazon tests how AI handles API failures for pricing and stock availability data. Second one is autonomous vehicles. AI stability in adversarial conditions. Self-driving cars rely on AI-powered perception system. Companies like Tesla have tested AI against sensor failures, adversaryal attacks, and unpredictable road accidents. Example, AI models are trained to still recognize stop signs even if they are particularly abstracted. Third one, financial AI systems. Stress testing for algorithmic trading. AI-driven trading models must respond instantly to the market fluctuations. Banks and hedge funds stimulate extreme market conditions to see if AI trading algorithm reacts correctly under volatility. In 2010, AI-driven trading failure wiped $1 trillion off of the stock market in minutes. This led to stronger resilience testing in finance. Fourth one is healthcare AI systems, ensuring medical AI reliability. AI is used for mechanical imaging, diagnosis, and patient monitoring. Hospitals now use chaos testing to ensure AI systems continuously functioning even if the patient's data is streamed suddenly becomes incomplete and corrupted. Example, AI used to detect cancer in X-rays is tested against noisy, distorted, or incomplete medical images. These real-world examples show that AI chaos engineering is not optional, it is necessary. But how do organizations implement it effectively? Let's look at some of the best practices. Best practices for implementing AI chaos engineering. Implementing chaos engineering in AI requires careful planning. Otherwise, we risk introducing failures that do more harm than good. First one, start small scale gradually. Instead of immediate raising of running large failure experiments, organizations should start small and control small scale testing. For example, an AI powered fraud detection system would first test against the minor data inconsistencies before stimulating major data losses. Second one, monitoring key AI performance metrics continuously. AI requires different monitoring than traditional softwares. Key metrics includes model accuracy and fairness, response time and latency, robustness against adversarial inputs. Example: AI used for loan approvals must remain fair across different geographical things and microservice stress conditions. Ensure ethical and regulatory compliance. Many AI failures have resulted in biased, unethical, legal, non-compliant decisions. Example: hiring AI model should be tested to ensure they don't unintentionally discriminate against certain applications. Integrate chaos engineering into MLOps pipelines. Chaos engineering should not be one-time process. It should be built into AI deployment cycle. For example, AI-powered chatbot should continuously be tested for robustness before every software update. By following these best practices, organization can make AI systems more resilient, ethical, and reliable. Now let's explore what's future of AI chaos engineering look like. Future of AI chaos engineering. As AI continues to advance, chaos engineering will evolve in several key ways. First one, self-healing AI systems. Future of AI systems will have a built-in self-healing mechanism that detects failures and automatically correct them. Example, a medical AI system would detect a drop in accuracy and automatically restrain itself for using for new patients. Ethical AI resilience testing. Regulatory bodies are pushing for AI fairness and explainability. All AI will be soon required to pass fairness test before they are allowed in production. A loan approval, for example, a loan approval AI will be tested under adversarial conditions to check if its unfair favors certain groups. Third one, AI powered chaos engineering. Instead of humans designing failure tests manually, AI will generate its own risk test scenarios. For example, AI will predict its own failure points and suggest customized resilience tests before deploying. Fourth one, more advanced AI observability. All AI monitorings will become more sophisticated with real-time detections and silent failures. Example: AI-powered cybersecurity system will continuously detect small anomalies before any escalates major breaches. These advancements will make AI more adaptive, attentive, and resilient in future. To summarize, we have covered why AI systems are vulnerable to unique failures, how chaos engineering helps detect and fix AI weaknesses, tools, frameworks, real world applications of AI chaos engineering, best practices, and future trends. Think of chaos engineering as a vaccination for AI systems, introducing small controlled failures to build resilience against real world issues. Thank you. I would love to hear you any questions.
Okay, thank you very much. This was session from Lakshmi Supriya Nama, and we are quickly moving to the next session from Kabir Ibrahim about AI-powered payment systems, opportunities and challenges. Let's go.
Hello, everyone. My name is Kabir Ibrahim, software engineer at Prune Payments, and I'm going to be giving a short talk on AI-powered payment systems and the opportunities and challenges around the applications of AI in the in payment systems, and how this has evolved over the years. And we are going to be going through a few examples and a few diagrams of how comparing how AI AI applications have actually influenced payment systems in the past few years. And yes, then we can get started. Just to go over a few things we'll be going through in this slide. We'll be talking through an introduction to AI, just a short introduction. I'm sure everybody already knows what AI is now, as that's it's what is currently in the technology space generally. We'll talk about applications of AI in the real world, just applications around different applications of what we use it for, before, and how it has evolved over the years, from rudimentary applications of AI to more advanced ones, that we can see from that we can see in everyday devices and things like that. Then we'll go into the nitty gritty of talking about AI in the payment systems. We'll talk through a couple of applications of AI in payment systems and different parts of payment systems that we can apply AI to. And then we'll talk about the application opportunities, also in payment systems for AI, in terms of how we can actually use AI, the opportunities that we can still use AI to influence payment systems as they grow and as it evolves later down the line. And then we can talk about the challenges and in the applications of AI too in payment systems. And this is a very this is very specific in a way, because different payment systems generally do not follow the same pattern across regions. The way payment systems work in Europe in Europe, like for SEPA, for example, is different from the way payment system work in the United States. It's different from the way payment systems would work in Europe in terms of infrastructure and in terms of flow. It's different. So there are different ways we can apply AI in different aspects in that way. And then we can talk about a few solutions and prospects around what we can also how we can improve on these influences, and what we can do to in the future to make things a bit more seamless for the applications of AI in these payment systems and things like that. So to get started, we can go to the next slide, where we do a short introduction of artificial intelligence, which we have two definitions here, just to make things simpler for the technical audience and our non-technical audience. To a layman, artificial intelligence is just is when we teach machines to mimic the way humans think and make decisions. A good example, or a more general example of to explain this to everyone, is always is when we an example that is used to describe AI mostly in the larger sense, is when we try to describe how does a human identify a dog, for example. We we say, oh, this is a dog based on its characteristics, or based on the way it looks, or based on the way it talk, or based on the way it barks. And there, this is a type of dog, a Labrador, a Dalmatian, or different types of dogs. You can identify them based on how they look. Now imagine we feeding this data to a machine or a computer, so they can identify those dogs based on the knowledge that we have. That is a short description, or a short way that you can actually describe artificial intelligence in simpler terms. But in more technical terms, we can actually describe AI as the ability to enable computers to, analyze data, make sense of it, just like we humans will do, and then make decisions around how they actually understand data, based on what is actually fed to the computer without direct or close human guidance. Let's put it. So that's basically, in more technical terms, or a short definition of AI in the larger sense of it. In the more technical sessions, there are aspects of AI that we can see in everyday work, where people describe things like machine learning, or deep learning, or more recently generative AI. These are also aspects of artificial intelligence. There's a diagram that shows that machine learning is a subset of artificial intelligence, and then we can also describe deep learning as a subset of machine learning, and then generative AI is a subset of deep learning. Because all these are intertwined, and they are basically ways that we can actually improve, or we can actually implement artificial intelligence in or apply artificial intelligence in various ways. If we go deeper into machine learning, you can go into like supervised learning or unsupervised learning, where computers can learn from previous decisions, or where they are allowed to make inference based on past decisions or past data that has actually been fed into them, for according to the data that has actually that according to data that has actually been fed over time, in that sense. So one important thing to note about machine learning, which is going to be applied, or is going to come to fore in later sections of our talk, is machine learning is basically we are giving the computer the ability to learn from data without explicitly telling or explicitly programming the machine to do particular actions, but we are feeding it data and we are telling it, oh, learn from this for you to be able to perform specific actions and things, and similar, and react similar to the way that data, based on the data that's actually being fed to it, in that sense. That is machine learning in the larger sense of it. But for this talk, we'll focus on AI as a whole, not on its subsets. There are various subsets of it and its applications now that we can actually go into. But for now, we'll actually go focus on the primary aspects of artificial intelligence in that sense. So to go on to the next slide, where we talk about AI in the real world. Basically, AI applications of AI in the real world has evolved over time. There has been various applications of it in the larger sense, in various machines or devices. In the early days, machine learning, or AI, in the AI, artificial intelligence in itself, was mostly theoretical for a very long time. The word AI has actually been around for a pretty long time practically for a pretty long time. But they were mostly theoretical, and were mostly used in academic research, to theorize how we can actually make machines better and make them evolve to do work better for us. But over time, we have actually seen applications of machine learning in our everyday, or artificial intelligence in our everyday devices, from recommendation systems to a good example I like to use is your keyboard autocorrect. Is something that has actually seen an application of artificial intelligence for a very long time, where your keyboard learns from what you type, and from the words that you have actually typed, even to the point of actually your pattern of typing. It can actually infer over time on, okay, what you actually want to write and how you want to write it. And it can make recommendations based on that. One of the few examples, one of the core features of this is like, for people that speak languages where they have like different dialects or different slangs, let's put it that way, attached to it. You can see your keyboard actually picking up on those slangs over time as you actually write them, which are not primary, maybe English or other words, but are words that you have actually used before. And in the context in which you're using it, your keyboard is able to predict, okay, this is what you actually want to write in that sense. And yeah, we've actually seen applications of artificial intelligence in virtual assistants like Siri and Alexa over time, where they can you can tell Alexa to play you music based on your mood, or tell Siri to 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 vacuum your apartment, and it connects to maybe your vacuum machine and is able to um, um, vacuum for you based on data that has actually been passed to it about your house, the size of it, and things like that. So and down the line, this has actually evolved also. We have actually seen artificial intelligence being applied in things like healthcare and diagnostics, where doctors have actually been able to do this for a while, where they machines that can actually look at particular test results and be able to make more identify better, where things like identifying tumors or cancerous cancerous cysts and things like that from imaging. This has because because machines are able to process large amounts of data, and based on data that they've actually been passed in, they are able to use that data to more correctly identify, maybe or more efficiently identify specific tumors or things like that, or cysts in imaging and other applications for a while. And lastly, which is going to be one of the core aspects of what we'll be talking about in payment systems, is in fraud detection. There are actually there's actually been applications of this of artificial intelligence in fraud detection systems for in payment systems for a while, where even big banks have actually, and even startups have actually been able to apply artificial intelligence to accurately detect pattern of fraud in specific payment systems, based on user patterns and payment patterns and things like that. Yeah, so we'll go deeper into this in later slides, where we talk about the further opportunities and how we can actually improve on the application of artificial intelligence in fraud detection systems and things like that. So yes, so going on to the next slide now, where we actually go into the aspect of the core aspect of our talk, where we are actually going to focus on payment systems and artificial intelligence applications in payment systems, and how we can actually improve, how we can apply them, the opportunities specifically for application of artificial intelligence in payment systems. Okay. Yeah. Artificial intelligence has actually had various applications in various parts of payment systems. Just to go back a few steps, one of some of the core aspects of payment systems where artificial intelligence can actually be applied to are a few, in terms of some and one of the core aspects is fraud detection, where artificial intelligence has actually proved very, very useful in helping to analyze fraud patterns and detect fraud faster and more efficiently than legacy systems. We're going to go a bit deeper into this in later slides, where we look at how this can actually look in terms of architecture, and how fraud detection, artificial intelligence has actually made fraud detection more seamless and more efficient in payment systems. And also we can talk about how we can also improve upon it, potential improvements that can actually happen down the line to actually help improve payment, the application of artificial intelligence in fraud detection and things and the likes. Also in payment processing and integrations. Integrations are a very big core part of payment. Most payment systems involve integrating into multiple services, or plugging into multiple services for various processes. For example, say a payment system would traditionally be paid into multiple channels. Channels are the right word. So let's say you're paying ACH payments, or you're paying Swift payments, or you're making SEPA payments, or you're making faster payments, like in the UK. This kind of payment, this payment system as a whole generally has several channels with different integrations for these channels, and artificial intelligence has actually proved very useful in helping to route payments within a channel in the most efficient manner, based on data, and also based on historical data of efficiency, or maybe time of day and the likes. That is actually very, very useful. And one of the newer applications of artificial intelligence has actually seen an application in payment systems that's actually been in ongoing KYC monitoring, and even KYC monitoring as a whole. KYC or KYB is one of the very core aspects of most payment systems, at least most modern payment systems, where regulatory bodies in various countries or various jurisdictions require companies that build payment infrastructure or payment systems to align to specific KYC requirements of KYC procedures. And this is actually it's inevitable for a larger payment system to carry out KYC monitoring. And one of the aspects of KYC monitoring is also ongoing KYC monitoring, or KYC, in terms of where KYC is carried out on an interval or on a day-to-day basis to check if any there's potential for exposure within the users of the payment system, or within a particular transaction of the payment system on a day-to-day basis, to make sure that the system is always in line with the regulatory KYC checks or KYC procedures that are actually required in that sense. And some of the applications has also been in payment analytics and business information, where we artificial intelligence has actually be proved very useful in helping to provide good analytic insights into payment behaviors and payment procedures for businesses, and how infrastructure providers of payment systems as a whole can make their services better by providing them with adequate data potential user behavior, or even based on user historical behaviors of similar payment systems, and the likes. Also, in terms of customer support, has actually artificial intelligence has actually proved very, very useful in this sense, because gone are the days where we have to wait in line to actually answer basic questions for payment system, in actual payment infrastructure, where we have to wait to chat with like an actual user in payment to actually solve our problems. Now there are AI chatbots that have actually proved very, very useful for us to be able to for us to be able to answer the most basic questions in this kind of payment systems, and be able to allow us to solve our problems before, and in the most extreme cases, then we can actually be referred to like an actual user, or actual human to talk to, in that sense. So just to go a bit further into some of these aspects, into one of the core aspects we talked about earlier was in fraud detection. The technical implementation of fraud detection has actually evolved over time, in terms of um, how fraud detection usually worked in legacy payment systems, usually involved where a transaction comes into the payment system, and what usually happens is that this transaction is run through various fraud detection rules to check, oh, does it trigger this rule, does it trigger a PEP rule, does it trigger fraudulent pattern, this fraudulent pattern. Also, there's a need in legacy payment systems. There was a need to define almost all the possible fraud patterns for the payments to actually be run through to see if this fraud pattern is actually checked for each of the payment pattern for each of the payments, and this is inevitably grows cumbersome across board for various for as payment infrastructure become grows, and imagine a payment running through 10, 20 checks before it's actually processed. This is going to delay payments, and also put a whole load on infrastructure cost and things like that. So, but with the introduction of AI, fraud detection systems have actually evolved past this legacy system, and you can actually see scenarios now where when a payment is actually initialized, um, there are AI systems that have actually been trained to, instead of running through all the possible rules, they run through the specific rules that are targeted for that particular payment. So, for example, if a user in a is already flagged as a suspicious person, there are specific rules that they will be run through, and the AI agent already knows, okay, these are the rules that I should run for this particular user, which makes things more efficient, saves cost, saves compute cost, saves time, and also it also makes the AI algorithm better, as you actually process as many payments as possible as you go on. And also it's also able to, introduce, it's also easy to introduce newer patterns for these AI systems to run through, for them to actually know that, okay, this particular pattern is actually apply can actually be applied to this rule, in that sense. And yeah, that's it. And also this has actually made fraud detection systems are actually better within payment systems a whole lot. And this is even evolving better now with the introduction of more efficient AI agents, and more efficient generative AI patterns. You can There is need for these fraud detection systems to even get better, because you can actually with generative AI, you can't even trust voice recognition anymore, or video recognition for two-factor payments. There's a need for this. For the AI is actually it's like AI detecting AI, for us to be able to know, okay, this voice recognition, or for payment system that use voice recognition, is actually being fraudulent, and is actually generated by AI, and the likes. Just The next part of this is actually payment processes, which we talked about earlier, in terms of the different channels which AI, which payment go run through, are usually diverse, and they are usually primary channels, and secondary channels, where payments is actually funneled through a particular channel. And then if there's a failure, then it goes to the fallback, and the fallback, and the fallback, just to make sure that payments are actually run through efficiently. But with the introduction of AI systems into this pattern, it has actually made it easier for this for payment systems to find the most efficient gateways to actually process payments, and to find the optimal route for payments to actually run through, in scenarios where there are failures, and even in scenarios where there are not failures. And in scenarios where there are failures, even these AI systems are able to, pick up on specific patterns, or pick up on specific patterns that can actually be reported to customer service or fraud systems, to even make the payment system more efficient and better as time goes on. And yeah, so this, with the introduction of AI into this, has actually made the payments processes easier, also made it faster, and made it more efficient. And with the introduction of analytics into it, is also able to provide us with real-time analytics into what is failing and how it's failing, for us to make these payment processes better as things goes on. Then also, for us to we've looked at the opportunities attached to AI, then we look at the challenges attached to the AI application in payment systems. One Some of them has actually will be the lack of adequate data to help make algorithms more reliable. This is much more much more pertinent in jurisdictions where data is data privacy rules prevent the provision of data pattern or data adequate data for us to make AI algorithms better from previous payments. And these are mostly data privacy issues that need to be addressed for us to make AI algorithms better, and also to protect payment systems as things goes on. And the regulations have also deterred innovation in the applications of AI in various parts of payment systems, like for example in data analytics. For example, there are jurisdictions where specific data can only be provided with user permission, and getting this permission can actually be tricky, especially for payments data. So this has actually hindered the application of AI in payment systems on a larger scale. And also the usual lack of research funding. This will always hinder innovation as time goes on, and also, as we talked about, data privacy rules and the likes from third party vendors. So yes, this is pretty much everything we have today in terms of AI in payment systems and challenges. I'm sure as we can usually think of better applications, and how we can actually evolve over time in this particular aspect. Thanks for listening, and yeah, thank you very much.
Thank you. Thank you very much, Kabir. Thank you for this overview of payment systems and AI. Thank you. That was cool. And next speaker is Dmitry Zolotukhin, and topic is Thompson sampling meets Uplift modeling, a reinforcement learning approach to subscription growth. Wow, let's go.
Good afternoon. My name is Dmitry Zolotukhin, and I am the Chief Data Officer at More.tv. I'll talk about how we approach the Uplift modeling challenge at our company. We will discuss how we frame the problem, the data we use to solve it, and how we work with that data. Next, we will focus on the process of training the models, and then challenges we tackled. Finally, we will review the results we obtained. A brief overview of our company. More.tv is an online video service where users can buy a subscription and renew it monthly, or use a trial period, or opt to watch ads instead of subscription. In the AVOD scenario, we earn revenue as an advertising platform. Our goal is to grow our subscriber base. One way to do this is by offering users a discount. The logic is simple. It's better to earn somewhat less from a user if that secures a recurring payment that is still more valuable than advertising revenue. However, the challenge is identifying users who would have subscribed without a discount, so we don't lose profit unnecessarily. Uplift modeling helps us solve it. The goal of Uplift modeling is to predict how users' direct variable, such as subscription purchases, would differ if they are targeted, for example, offered a discount, versus if they are not targeted. We can both target and not target the same person, so we really rely on the average treatment effect. The difference in subscription purchases between the group that received the discount test and the group that didn't, control. Because we randomly split the users into test and control, this matrix remains valid. In addition to predictive accuracy, our main non-functional requirements are stability and interpretability. They fall from the high cost of user acquisition and hence of user communication data, and from the elastic nature of movie TV shows demands. Since there are frequently new releases, the model must not overfit to specific shows, but should focus on more timeless indicators. We derived certain features per user, based on how they interact with Smart TV. The players, the search function, the project pages. For example, number of watched projects, project added to favorites, TV shows views, movie views successful. For example, in search interaction, average number of action between search and watch, and number of queries that yield no results. And from pages, it's more connected with similar to this. Most user activity in the player, so that's where the most features come from. Of course, we log far more data points, but we selected features most indicative of eventual subscription. Our selection criteria was the Gini score correlated each feature to conversion. Our processing follows as a standard flow. We split into training and test sets, train the model, then validate on a holdout set. We measure the score of both sets to ensure there is neither overfitting nor underfitting. That is, our model is ready. What is the score? Gini is the difference in the same share of successful conversion in testing versus control. But for more entire samples, the difference is always the same. So how do we incorporate the model prediction? We sort users in descending order of the prediction that uplift number of targets. For each segment, we calculate Gini among the users with a higher score. We then plot Gini against the number of users, producing something like the solid blue line on the chart. This is Gini curve, representing additional revenue. We compare it with the random assignment, not on order, the dashes line. The area between these curves is the Gini score we seek to maximize. Gini measure is the difference in successful conversion between the test and control. For total samples, the difference is static. To leverage our model prediction, we sort users by the predicted uplift and compute Gini step by step. Plotting this produces the Gini curve, which shows the potential extra gain from targeting. We compare that curve to a random baseline, and the area between them is the Gini score, our key metric. Data processing issues. Initially, we tried random splits. Each user had an equal probability of being in the training and test sets. However, we noticed that depending on how we split was done, model performing could swing to opposite extremes, either close to ideal or worse than random ranking. This was bad. To confirm that the issue was not merely unlucky validation sets, we fixed the validation set and assembled the training set from remaining samples, randomly with replacement, similar to a bootstrap approach. The validation scores still showed a wide variance, and the variance remained stable even after 400 experiments. This indicates we need different splitting approach to achieve stable results. The first step. Our first solution was to split users' registration date. We put the more experienced older users into the training test set and the newest user into the test set. This also nicely mirrors how we handle production, where the model will predict for new arrivals. We used 80% and 20% training validation split and trained an uplift random forest from the casual ML library. Looking at the graph, however, users are spread across a few distinct peaks, 1, 2, 3. You can't isolate the most promising users with one threshold, this one, or this one. There are 3 peaks, so we tried other approach as well. Our second approach was to stratification data. The hypothesis: if the features in the training and test sets are distributed similarly, and similarly to the population distribution, model results should be more stable. But which feature do we use to stratify? Including them all produces too many strata. So we settled on 3. The user's number of active days, where they converted, and where they were offered the discount. We choose number of active days because it has the highest Gini score for predicting subscription conversion. Let's back from the 5th slide. So, our goal is to end it with 80-20% into train tests. We first stratified to select 50% of the data at the initial training set. From the remaining half, we repeatedly sample 1,000 exams, reverse starting proportion, and then to the training set, train a model, and then test it on the leftover data. If the Gini on train and test differs by less 5% while outperforming random ranking, we keep this 1,000 samples in the training set. Otherwise, we discard them. We continue until the training set is 80% of the overall data. This reduces the number of peaks on the graph somewhat, but we still didn't see the desired tight clustering at the top of the ranking, because there is now 2 peaks, but we know which one we should choose. And to solve this problem, our third approach was to use Thompson sampling. The idea is that the remaining 50% of data, not in the training set, is split into clusters, and we pick data from the cluster with the highest rate of successful training attempts. This way, we incorporate prior iteration outcomes and any environmental changes. For each custos, we assign a beta distribution and update the parameter based on whether the training attempt was successful or not. As a result, the algorithm is similar to the previous one, except instead of pulling data from the entire pool, we pull it from just one of the 4 clusters. And after training, we adjust the beta distribution parameter for that cluster. In theory, this should converge to a better outcome. Unfortunately, in about half the cases, we can get it to converge within 10,000 iterations. So there's the steps. Half of that trained half pool, so we split 4 stratified clusters. And next. Our final methods combine data-based splitting with Thompson sampling. We first sort data from registered data. We first pick the oldest 50% of our users for training, and then draw from the other half in cluster via Thompson sampling. This approach almost always converges and learns to rank users more tightly near the top of the list. Yeah, and now we can, after this, see the first peak here, and we now can choose our threshold between this near this peak. Yeah. Now let's talk about A/B tests. To evaluate the model of loss performance, we take a cohort of new users on trial. 5% are offered no discount, and 5% recently discounted. This provides our gold standard, control and test groups to compare conversion and this if there are genuine effect. We score the remaining 90% with our model, select the top 20% by predicting uplift, this one, threshold, and give them all of them an offer. Then we compare subscription conversion. We accept the higher conversion among those offered the discount versus the non-discount group, while the group that didn't receive this offer should perform on par with no offer control group. So this with this with this. Meaning we are not losing potential subscribers who should have been given a discount. Next, we plan to test different discount among the lengths in the personalizing the offers even more. We also intend to find the optimal timing for discount, first, second, or third week of initial period. Also, the experience with offer first users who have multiply subscription already, for example, Uplift for person with first or second subscription will not churn them. So that's all. Let's a little bit remind you what we are talking about. First of all, we used Uplift modeling for our problem with discount. As our score, we use model Uplift, and score as a Gini. What is the difference between conversion on control random group and our Uplift group test group. After that, we met some problem with random split, so we choose the next one step with split by registration date. After that, we used our random stratification. That's how we changed our Gini curve. And the next step was Thompson sampling, the third step, which showed us the best Gini curve, but it's not ready to choose our threshold for use it. And after that, as a final step, we combine the first one with registration date and Thompson sampling, and we received this one curve. And now we can choose our Gini threshold as 20%. So that's all. Thank you for watching. Have a nice day. Bye.
And welcome back, dear audience. One block left. We did good. Bunch of cool stuff, technical information, and everything. And we're moving towards our next speaker, Mikhail Baranov, AI-driven cybersecurity. How we reduced costs by millions with strategic security initiatives.
Good day, colleagues. I'm Mikhail, Head of Security Engineering and Operations. Today, I'll walk you through how AI transformed our cybersecurity framework, improving efficiency and leading to multi-million-dollar savings. Let's begin with the initial conditions. So they are four of them. Global financial institution processing billions of transactions. Threats, APTs, zero-day exploits, state-sponsored attacks, anything you can imagine. Fragmenting security framework across regions, estimated financial impact of breaches up to $500 million annually. So there were several major security gaps we've identified, from fragmented policies, increasing attack sophistication, to massive financial risks. With APTs, zero days exploits, and state-sponsored attacks targeting us, the stakes were quite high. A breach could lead to costs up to $500 million annually in losses, fines, and disruptions, or anything of that. It was clear that we needed a radical AI-driven transformation to stay ahead of those. So that's how we began. We decided that the transformation plan should be AI-powered for sure. So our security needed a complete overhaul. Following what you see in the slide, we developed a unified AI-driven strategy to eliminate inefficiencies and enhance threat detection, automate responses, and minimize manual workload. Instead of relying on fragmented tools and slow manual processes, we leveraged AI at every stage, from real-time threat monitoring to automated incident response. The goal was simple: to detect the threats faster, respond proactively, and free up our security teams to focus on critical risks rather than on routine tasks. This transformation became a game changer for our security posture. So we began an AI-powered security assessment. AI transformed our security assessments, making them faster, more accurate, and significantly more efficient. For example, vulnerability scanning. AI reduced remediation time by 35%, reducing manual workload and manual efforts dramatically. The penetration testing, one could say that I think that should be performed only by a man, and the AI and robots could barely help there. But in our case, AI identified misconfigurations in 15 minutes versus manually. That saved us around 20 workdays in process of security assessment. That's an important thing, because in security assessments, those should be performed in a quick pace, right? So any delay in security assessments and the delivering the results of the security assessments to the management of the company could cost millions of dollars, and in some cases even the company existence overall. Regards the configuration auditing, AI mapped data flows in weeks versus months. So the problem was that the data flow within the company was quite a bulk and volatile thing for anyone inside the company. So, but without the detailed data flows, it was quite impossible to determine the exact location of the critical files and all the stuff, critical data. Application security testing, AI-assisted code review reduced vulnerability analysis time by 30%. Employee awareness, that the thing where AI came in handy as well. So AI-driven training reduced phishing click rates from 35% to 10%. These AI-driven improvements didn't just enhance security, they freed up our teams to focus on more strategic initiatives instead of spending hours and hours, countless hours on manual assessments. There we go. So once we've finalized the assessment, we have to perform the risk assessment. So the implementation of AI-driven risk modeling has provided invaluable insights into the financial risks faced by the organization, offering a clear picture of potential vulnerabilities. Key findings include potential losses, regulatory fines, reputational damage. This quantifiable risk highlight the need for robust risk management strategies to safeguard against significant financial and reputational impacts. The thing we began with in terms of engineering, right, that was a microsegmentation, and the AI-driven microsegmentation enhances network security by moving beyond the traditional static segmentation. While traditional segmentation relies on predefined access controls, AI-based microsegmentation adopts security policies based on real traffic monitoring, dynamically isolating suspicious activity. This approach allows security teams and companies for real-time threat blocking, offering more effective protection. Additionally, traditional network segmentation wasn't enough in the company where the transformation took place. AI-driven microsegmentation enabled dynamic security adjustments, blocking threats in real time. By leveraging AI technologies, organizations can more effectively identify and respond to security threats. Innovations include AI-enhanced SIM, which allowed real-time log analysis and anomaly detection in the blink of an eye. The second point is the user identity behavioral analysis. That's mostly related to insider threats, right? And based on the user activity monitoring. So AI detected insider threats based on behavior anomalies mostly. And the overall outcome was AI automatically flagged high-risk activity, reducing detection time by 60%, which is quite impressive in terms of what it was and the state after the transformation. So another key thing I would like to mention here is the AI-powered endpoint protection. So let's explore how AI-powered endpoint protection and transforming security operations. AI identified behavioral deviations and automatically isolated infected endpoints, reduced manual workload by 60%, and containment time reduced by 80%. Quite impressive. So to sum up, AI-driven endpoint protection automated threat isolation, minimizing risk while reducing the workload for security teams. The thing which is a headache in each and every organization right now, it's the identity and access management, right? The fundamental thing for security in depth and zero trust and all these concepts. So as you can see, AI enhances security measures such as multi-factor authentication and role-based access control. By dynamically adjusting security levels and preventing privilege escalation, AI strengthens access management. As a result, organizations experience a 30% reduction in manual access reviews, streamlining security operations and improving overall efficiency. AI-powered SOAR automation improved incident response speed, drastically reducing containment time and minimizing potential damage. This leads to more proactive and efficient threat management, ultimately protecting the organization from greater harm. Let's jump into some case studies. So the first case study is about the preventing an APT attack, a sophisticated APT attack. So APT group launched a phishing attack that exploited zero-day vulnerabilities. Unfortunately, I can't jump into the details, due to non-disclosure agreements we have with the companies. So yeah, but regards the detection and response. So AI-enhanced SIM detected anomalies, while AI-driven SOR playbooks automatically isolated the threats. As an end outcome, right after the transformation, the attack was successfully prevented, avoiding potential losses, which could lead to severe disruption and loss of customer trust. So in this first case, AI detected a sophisticated phishing attack earlier than that would be human, right? So you don't need to rely on humans anymore. I mean, on their how they concentrate on the work, all the stuff. So in the first case, AI detected a sophisticated phishing attack earlier, allowing us to neutralize it before it could cause financial and reputational damage. The second case is related more to the in-deep, I would say, the in-deep attack, right after the phishing was successful. So an employee unknowingly executed ransomware. AI-based EDR identified abnormal file encryption patterns, and AI automatically isolated the device while locking the user account. So one more insight. So we have a tool for microsegmentation, both software and hardware microsegmentation, and AI was integrated with them. So AI based on the pattern, it identified the issue, that the attacks taking place, and created the rules automatically and deployed them automatically. Well, it's still quite risky to allow AI to implement the rules, such as blocking rules. We defined that it would be nice to have such requests for the such. We identified that it would be nice to have sort of a test group of the users where these capabilities of AI would be in place. And we did miss. As you may see, it successfully prevented the attack, so we were more than happy with these results. So yeah, the financial and strategic impact, the most important thing in each and every project right now, and anytime actually. So the loss prevention, over 20 millions of dollars saved from the prevented breaches right after the implementation. Cost reduction, annual savings of around 8 millions through automation and reducing the manual efforts and the routine tasks. And in terms of the ROI, the most important thing as a result is 60% of return on security investments within 2 years after finish. So as you have noticed, the numbers speak for themselves. There have been substantial financial and strategic benefits realized through the AI-driven security measures. Ultimately, AI-driven security paid off, significantly reducing costs while strengthening our defenses. So based on our experience, I would like to share some key recommendations for each organization who would like to start the security transformation and currently thinking if the AI is think to implement as part of transformation or look a bit later on it. So a crucial part that should not be forgotten in security under any circumstances in order for organization to enhance their security posture is that they should focus on several strategic recommendations that integrate advanced technologies such as AI and protective measures. So first of all, invest in AI-driven security tools, adopt multi-layered security and defense in depth, foster a security-aware culture with AI-driven training, standardize security policies with AI. That's mostly related to the security standards and security guidelines. But in some cases, AI could be used in policies as well. And of course, align security with business goals through financial impact modeling. I won't tell names, right, of the AIs we've used, but as you probably know, most of the AIs currently were trained using several different business models, financial impact modeling, business impact analysis, and all the stuff. So they do their part in a quick and effective way. Sometimes, of course, there are some failures and issues, but trust me, the time, security, and the rest of the technology spent on the such tasks decreased dramatically. So The integration of this recommendation not only thanks defenses but also delivers measurable financial benefits, empowering businesses to thrive in an increasingly complex threat landscape. So, as a conclusion, AI-driven cybersecurity is the future. It has transformed how we defend against threats, reduce costs, and enhance security resilience. And to elaborate even more, AI has transformed cybersecurity strategy by automating security operations, leading to increasing efficiency and significant cost savings. Additionally, AI-driven risk assessments have also helped justify security investments, ensuring a more proactive and cost-effective approach for projects that really strengthen your security within the company. And looking ahead, continuous improvements in AI will further optimize security, strengthening defenses, and enhancing overall resilience. So, colleagues, that sums up my presentation for today. Please do not hesitate if you have any questions.
All right. Thank you very much, Mikhail, for your use case. Really amazing. Great experience. And let's go to our next speaker, Raman Kapoor, applying AI with trusted data for cloud migration. Let's go.
Hi everyone, thank you for joining me today. My name is Raman. I have 20 years of IT experience and have worked across private and public sectors. At present, I'm working with UK Research and Innovation as Head of Data. I specialize in leading data engineering, data analytics, and AI practices. Over the past few years, my main focus has been on the data projects, which help industries making smarter decisions and resolving real-world problems using data, whether it's in the cloud or on-premise. My recent project has been building Geekle-like projects, cloud migrations, smart meterings, and a lot of automations. Today I'm going to talk about applying AI through trusted data for cloud migrations. We all are an AI bandwagon, which is gaining traction across most of the industrial sectors nowadays. But is AI the first step or something else? Let's find it out. Understanding your data, shifting everything from on-premise to the cloud in today's world is a major turning point, and the key reason for such transformation is due to exponential growth of data, which is generating every second in numerous formats and from the different sources. Understanding your data and inventories, ensuring data integrity, accuracy, and identifying the data sources and formats is a key critical step before moving forward with any cloud migrations or implementing AI. Let's understand what the data means. Data types helps us identifying type of data from different sources. Understanding where the data source comes from. It may come from the databases, spreadsheets, external sources, sensors, or third-party providers. Data quality plays an important role in assessing the accuracy, completeness, consistency, and reliability of the data. This helps us identifying all the errors, missing values, or any inconsistencies during early stages. Data relationships helps us understanding how different pieces of data relates to one another. For example, recognizing how any variables or data points connect or influence each other. The data structure helps us knowing how the data is organized, such as whether it is in the tables, files, or the different formats altogether. Data trends helps us quite prominently in analyzing patterns, correlations, or trends in the data to help us inform decisions, identify potential issues, or discovering the new insights. Last but not the least, data governance helps us ensuring that the data is properly managed, secure, and compliant with any relevant regulations. Now let's understand what our inventories looks like. The data catalog helps us identifying list of all the datasets, databases, files, or system where data is stored. Data organization helps us understanding how the data is structured within these inventories. Now let's look at the metadata, which always helps us in providing context where the data is, how the data can be accessed, where the data is located, how much frequent we can access the data. Data ownership and accessibility helps us knowing who owns the data, who has access to it, how he can access to it, what are the different permissions for accessing this. Data usage and applications helps us understanding how each data is used within your organization for consumption purpose, decision makings, and for the governance purpose. Data retentions and the life cycle helps us understanding how long each piece of data information is stored, where it is stored, when it is archived, and when it needs to be deleted based on the retention period. Let's understand the data integrity. What is data integrity? Data integrity refers to the consistency, reliability, and correctness of data over its life cycle. It always helps us ensure that data remains intact, unaltered, and accurately reflects the real-world scenarios. What is data accuracy? Data accuracy refers to how correctly data represents the real-world entity, or even it is intended to describe. Accurate data is always free from errors and reflect the true value or measurement. The key aspect of data accuracy includes certain parameters like correct precisions, correctness all the time, the timeliness of the data, completeness of the data, and source validations, which means the data has to be corrected at the source instead of correcting at the destination. What kind of different data sources we may have? We may have a primary or the secondary sources itself. Primary sources directly from the customers, from the social medias, or secondary sources, it is fed into the different sources, into the files or spreadsheet or the systems through the different media itself. We may have an example of different sources like surveys, questionnaires, experiments or the studies, transactional or operational systems like ERPs, CRMs, sensor data, research papers. So we have different data sources which continue feeds into our repositories. What can be the different data collections method? And let's understand how data is collected, and it helps us assessing its relevance and accuracies. The common methods for data collections can be very manual collections, or it can be semi-automated or automated data collections method. Data formats can be a vast format. We can have a semi-structured, we can have unstructured, or the structured data, which is highly scalable. The structured data comes mostly in the form of tabular form, like databases, spreadsheet, or the tables. Unstructured data is directly from the social medias in a different formats, text, images, videos, files, and the semi-structures can be the XMLs, JSON, and many other different sources. What are the data access and permission? These always helps us knowing who can have access to our data and how. It helps us understanding key component of the data management all the time, during migration, before migration, and post migrations. Access level helps us identifying who can view or modify your data. Is there a system of permission in place to protect sensitive data as per the GDPR rule? Data governance helps us identifying the rules, policies, or regulations that governs the use of data. Let's identify common data quality issues which we want to address before starting any cloud migration journey. Common data issues are missing data, which means any incomplete records, missing values, duplicate data entries which may exist in the system all the time, inconsistent data, which means variations in the data formats, be it due to different date formats, roundings, etc. Incorrect data due to outliers that do not make sense at all. Outdated data, which means records that are no longer relevant or valid or no longer in the use. Now let's see how to clean data using AI. AI tools can help us finding missing data intelligently by learning patterns from the existing data. Methods such as regression analysis, nearest neighbor algorithms, or deep learning models which can predict and attribute missing values with the help of data robots, refactor-like tools and services. AI algorithms helps us identifying duplicate data detections and removal of data with the help of fuzzy matching algorithms and logic, which can detect near identical record with very minor variations such as spelling mistakes or inconsistent capitalization. AI can always help us standardizing and normalize the data consistencies in the right data formats, units, and values as per the expected outcomes. We can always automate the processes by running advanced data profiling tasks identifying patterns, and flagging potential problems for data organization time to time. We know that data is not right always. If we are not addressing known data issues and gaps in early stages, it will delay overall migration process and lead to the unexpected challenges and complications. When data is curated in early stages and well organized from the very start, it makes entire migration process smoother and faster. This doesn't accelerate migration journey only, but it also lays the foundation for successful AI models. Clean data means AI models can run more faster, efficient, leading to more reliable insights and smarter decision making. Let's find the key steps for successful migration journey. Here we are to review all the steps for successful cloud migration journey. Cleanse your data before migration itself. Ensure the data is accurate, consistent, and free from errors to establish trust. Clean data layers lays solid foundations to run AI models effectively and more efficiently. Identify key data sources. Determine which datasets are most crucial for migration and will benefit most from AI analysis. Select the right AI tools. Choose AI tools which aligns with your cloud migration journey and can handle your data needs efficiently with right tools and services such as data robots or refactors for the data cleaning or cloud services for predictive analysis. Define clear migration goals. Establish objectives like improved performance, cost efficiency, or scalability that AI and trusted data can help achieve. Cleaning data earlier makes migration more efficient and faster with few or no issues at all. Implement data securities and governance. Ensure data privacy, compliance are maintained throughout the migration process. Run pilot programs, test AI algorithms and migrations process on a small scales MVPs to identify potential issues before full migration itself. Monitor and optimize. Continuously monitor the migration process to avoid potential problems and optimize performance time to time. Making research data more appropriate for machine read abilities. Supporting text and data mining as a standard and essential tool for your research and for future requirements like topic modeling, tagging. All of these steps will make migration more efficient and prepare you to use AI for better results. When data is accurate and well organized, AI models can deliver more reliable insights and make more smarter decisions with improved outcomes. By curating data properly before migrating from any source system to destination, the overall process becomes more reliable and efficient. So, focusing on the clean data at early stages speeds up the journey to the overall cloud migration process, and it also boosts the impact of AI in driving better business decisions and outcome. Thank you for your participation. Please reach out to me if you have any follow-up questions. Thank you.
Thank you. Thank you very much, Raman. Thank you very much for your session. And last speaker for today and for all our AI Transformation Summit is Samira Nagasinghe, AI-driven transformation, optimizing costs, enhancing services, and scaling agility.
Good morning, good afternoon. Thank you for joining the AI Transformational Summit. I'm Samita Nagasinghe. I thought it's fitting to start this presentation with a quick introduction into myself. I have been in the IT industry for over 17 years. I have been catering telecom and fintech clients primarily. I have worked with numerous technological platforms, languages, AI solutions. My experience and expertise mainly lie on business development, product development and growth, operations, and project management. Out of all my experiences, I'm here today to talk a little bit about AI-driven transformation, how we could utilize the power of AI to optimize costs, enhance services to end clients, and for scaling in agility, all targeting enterprise level clients. Before we dive deep into the presentation, I would like to give a quick introduction into the tech. Imagine a world where enterprises could improve productivity up to 40%, do cost reductions in similar magnitudes, or even improve customer loyalty, customer satisfactions drastically. It is not a dream or a wish. With today's AI boom and the AI technology, this is now a reality. On today's presentation, I would like to go through a couple of use cases, examples where how other organizations have harnessed the power of AI to achieve everything that I mentioned. And I will also explain how you could utilize the same to make improvements within your organizations, have better productivity, reduce costs, and improve on agility. With that in mind, let's move forward. Next, let's talk about building an AI-centric business culture. What is an AI-centric business culture? This is a culture that we would recommend, promote for an organization who wants to gain the benefits of artificial intelligence to their organization. When we talk about AI-centric business culture, it's absolutely important that you promote your organization, employees, teams, colleagues to think out of the box, do continuous learning, improve themselves. And it's also absolutely important that organizations do not persecute failure. It's impossible to get something right 100% on the first try, especially when something is really new to the market, where all other companies are still doing a lot of trial and error. In a scenario like that, it is absolutely important to keep the teams motivated, push them towards the right direction, provide sufficient training so that they can educate themselves and do better, especially when it comes to AI-based implementations. And if you are an organization who is just starting on this AI bandwagon, you are still not late. If you have made the decision to do these implementations, you are definitely on the right track. You should continue. But one thing I would advise is you should think twice before you select your AI platforms, AI infrastructure. In a practical world, these implementations usually start with a pilot project. You would try it out, see how it goes, get the feedback. If everything goes well, if the desired effect is there, you would implement it organization-wide. But when it comes to that point, if you figure out your infrastructure is not scalable, the frameworks you selected does not support the usage, the functionality requirements, or if the platform itself is not productive enough, you are going to incur so much cost on a cloud platform rather than saving it. So do your research, make sure you select the right platform, right infrastructure, and you should be all good. I'll be talking a little bit more in depth on these points, how you can do, and some of my personal experiences itself on the upcoming slides. So we talked a little bit about the benefits of having AI integrated into your business model. But unfortunately, that integration is not going to be pretty straightforward, seamlessly getting integrated into everything. Wish it would happen, but in reality, there are so many challenges when you try to do an AI integration into an existing business model. Primarily starting off with data privacy and security concerns. When you are taking a platform or an infrastructure, you need to take into considerations your organizational privacy policy. If you have region or country-based regulatory requirements, all of these things has to be considered. So the good example, if an organization is kind of thinking of having ChatGPT as a virtual assistant, that is definitely going to impact the privacy policy, and of course data security is a concern. So it's absolutely important and vital an organization kind of think about these points at the very beginning, ideally when they are doing the POC, the proof of concept. If you try to do these changes somewhere down the line, it's going to be more costly than a benefit for the organization. Secondly, your human resource. So humans itself are resistant to change. We do not want to change. We want to stay the way we are. I'm like that, you're like that. That's how we are. So that's why there's something called change management in organizations. So it's very important to create this culture where it fosters these AI challenges. Those could be brought in as business unit targets, could be attached with bonuses, salary increments, promotions, could be brought in so many different ways where it actually motivates your staff, your colleagues. One organization I worked in the past, this is not directly for AI, but I think the example is nevertheless still valid. They were trying to move into Agile to be implemented organization-wide. So they created this campaign called Via Agile. They printed it on t-shirts, mugs, wherever you see Via Agile. So that kind of created the nice culture or that atmosphere that you want when you want to do some changes. So it gets everyone's mindset in the right way, and everyone keeps moving on the right direction. So something like that. Next, cost. So the moment you talk about improving or business process changes, one of the primary questions that you would get is about cost. How much is it going to cost now? How much is it going to cost in the future? How far before the organization could break even on the additional costs that you're going to incur? And some of these costs are going to be direct, like for example, if you have like a new infrastructure, it could be like a direct cost. And also there are indirect costs where you might have to train your staff, or there's a learning curve for your team, or there are a lot of trial and errors in the path where you're going to do the improvements. So all of these things indirectly or directly contributes to a cost. So it's important you make sure you don't overdo it as well, but you sit as a team, make sure you align the AI approach to the business objectives. That way, as you progress on your AI implementation, you can see the business goals are going to improve as well directly. So I believe that is one approach you could take to deal with these cost issues. Now that we talked about what we need to consider before we implement AI into a business process or creating a AI-centric business culture, I would like to talk a little bit about how artificial intelligence can help improve the productivity and the efficiency in pretty much any organization. So if your organization has any kind of a repetitive task, it could be filling a form every time a customer comes in, or I have seen organizations where different departments send reports using Excel documents, and there's someone always trying to put everything together to create a summary view for the executive team. So any of those things could pretty much be automated with the help of artificial intelligence. And apart from that, you could utilize artificial intelligence in decision making. AI is really good in looking into trends, doing predictions. And in fact, there was a research done by McKinsey where they found out organizations basically utilizing artificial intelligence have about 25% increase in operational efficiency. That's something really, really good. That is what you should target to achieve by having artificial intelligence. It is not to replace, but to improve whatever you are doing already. And also, when you are trying to do an AI implementation, one additional benefit would be less technical debt. So technical debt in the common sense is that you keep on improving on a product or a services or a software, and eventually you forget to do full testing, test automations, code coverage, etc. And eventually you are going to build up a debt where you need to do so much more code coverage, automations, improvements, security improvements, tests, etc., etc., etc. All of this is called technical debt. So having artificial intelligence and automating a software development process, automating agile sprints, automating story creation, all of these things could help reduce technical debt, because the artificial intelligence is going to make sure it's going to cover all the areas, all the needed areas. And also it could help reduce compute. So compute in the common sense is that when you look into cloud platforms, these days everything is on the cloud. All the products are trying to be SaaS. So compute is the resources that you have within a cloud platform, like the CPU, RAM, storage, etc., network, things like that. So when you have a system built so efficiently, when you get the help of artificial intelligence to do code reviews, make sure all the functions are efficient as it could be, all the coding is as secure as it could be, you are going to save on the resources you used on your cloud platform. So that is definitely an additional benefit of implementing artificial intelligence. Next, I have a case study from an insurance organization with 5,000 plus employees and working on 19 geolocations. So they went forward on digitizing their expense management process. They were able to do about 100% of the entire process. So for example, they could have a KYC, a know your client process. This is what you like fill in a bank when you want to get like a bank facility. So there's something called eKYC, digitizing these processes. So the clients could do it from their phone, a website. They can do it leisurely without having to discuss about private information with another person. So through this digitization of 100% workflows, they were able to gain massive error reductions, so much more customer satisfactions, and of course employee satisfaction as well, because they don't have to deal with these manual repetitive things again and again and again. So this is a wonderful example of how an organization can utilize digitization, especially with artificial intelligence coupled with digitizations, to improve their entire workflows. Next, let's look into the AI's role in digital service domain, especially in telecom. I myself have worked on multiple self-care products in the past, and the primary purpose of a self-care application is that the end user could get the services, resolve issues without the need of an actual human agent. So they can get things done fast, quick, efficiently whenever they want to gain those things, whether it's day or night. The moment artificial intelligence came with virtual agents, all of these telecoms jumped into the bandwagon, and they all of them basically wanted to have a digital agent. Probably they thought of a digital agent as a replacement of actual human agents, where the artificial intelligence could reply to humans without emotions, without failure or mistakes. So one thing I can share as a real world experience. It's absolutely important to define limits when you introduce a new service. One mistake that was done by these telecoms is trying to replace the human agent with virtual agents. Now, if an end user is coming to either activate a service or check their bill, check their data limits, whatever, it is a minor activity. It's not a sensitive activity. So if the digital agent could, or the virtual assistant could facilitate that service, wonderful. They're going to be happy, all good. If there are complications and the virtual assistant is unable to provide that service, still not going to be the end of the world. It's a simple request. The client or the end customer is going to still be okay to come back the next day to get it resolved. However, there's going to be a subset of customers who comes to these platforms with serious matters. Phone lines being disconnected, bill charges that are not recognized, etc. And if the virtual assistant could handle it, wonderful. But if they do not handle it with the empathy that is needed for scenarios like that, that is going to result in a really, really negative feedback by the client, including leaving the network itself. So my advice, always think of the human factor when you introduce AI services or when you digitize workflows. However, it is absolutely true that by having virtual assistants or virtual agents, organizations could operate far more efficiently, have 24/7 call centers, chats being enabled, and they can work continuously and answer repetitive questions without getting tired. So absolutely, these telecoms noticed about a 50% gain on their customer satisfaction. Also, when it comes to automated issue resolutions, AI is pretty good with handling tickets, taking issues through workflows, doing the needed escalations when it is required. But however, as I mentioned earlier, provisions for such escalations should be introduced to those workflows at the very beginning. And of course, telecom operators have identified significant improvements or values, especially in early detection of network issues. These days, everything's about the service. No one wants to lose their service or go into a blackout. So having these early detections, being able to detect flows, being able to detect trends have definitely helped these large organizations to be on the top of their game. And also, one other field that is gaining good improvement from artificial intelligence is the fraud detections. AI is more than capable of looking at a picture and tell if it's like a fake ID or a genuine ID. There are so many algorithm mechanisms built around those things. So it is predicted a huge boom in those industries for those organizations working on enhancing fraud detection. Few figures to further strengthen my previous points. By having AI chatbots, organizations have noticed about 20% productivity improvement. About 70% of the customer complaints were able to be resolved by the virtual assistant itself. And by having all of that automated, those organizations or telecoms were able to have a cost reduction of 40%, which is huge. So that's the power of AI. AI-driven predictive analytics in telecom. So this is a really sensitive and critical topic. When it comes to telecoms, they need to make sure the client doesn't churn. So I have worked with a telecom client in the past where they kind of mined all of the incoming data overnight and first thing in the morning, the sales team or the marketing team gets a report on the trends, customer sentiments, what kind of a data they have received from the previous day. The first thing they do in the beginning of the day is create offers, create new packages, and try to see how much they can prevent from those predicted churns. So having AI apparently have been able to provide about 85% of accurate predictions, which is huge when it comes to telecom and especially in the fintech sector. Having these predictions is absolutely vital for them. Next, let's talk about AI-powered agile workflow automations. We all know agile, we all like agile. We have seen how agile can assist all of us. Now that we have AI-powered tools, like for example Jira with AI, that can assist this agile workflow better, let's look into a few advantages that we can look to have. So primarily data-driven decisions, these agile automation should be able to assist the product owners, assist the scrum masters to pick the right stories, prioritize the right task, make sure there's not going to be any technical debt in the future. And also when it comes to workflows, if there are multiple departments being involved, these workflows could pretty much be automated 100%, where the workflows will send the product or the requirements to the right department on the right time, making sure no one loses time. Task prioritization can be done with AI, taking into consideration the team members' experience, their specialties, etc., so that there's no effort being wasted at all. It is been estimated that about 40% of effort reductions can be achieved by automating an agile process. Next, I have a quick case study done by Google itself. So they have created artificial intelligence to analyze their sprints, especially when you have multiple sprints running for a similar product or a similar business case. It's going to be absolutely hard for a human to kind of track everything and make sure they are on top of things. So that is where we can specially utilize platforms like AI for benefit. So this platform they have utilized ran across multiple sprints, looking into trends. It was looking into bottlenecks. It was looking into issues and resolution times, so that everyone was aware on what is going on. And then ideally, I assume all of this help do a realistic prediction, which is absolutely valuable when it comes to Scrum and Agile. And the outcome of this exercise was having 15% reduction in development cycles before the product went to the market, increased the development productivity. The AI was able to assist better on grooming and better prioritization of backlog tasks, and also to make sure and mitigate risk management proactively. So looking into all of these points, I think we all can now understand how and why it is absolutely important to improve the well-known agile process with the help of AI tools. So what did we discuss today? We discussed about creating a AI-centric business culture where the organization itself promote these changes. And by doing so, we discussed how AI-powered automation and innovation could drive operational efficiency, productivity, and cost reduction. We talked about strategic AI adoption and how it could provide a competitive edge in your business. Finally, we spoke about AI-driven digital service solutions, especially for telecom and field tech organizations, and how they have utilized AI to improve their services. AI is revolutionizing the market. I firmly believe we are just seeing the tip of the iceberg. How AI will evolve in the future, how it will be utilized is yet to be seen. And who make those decisions? We as professionals do, you, me, and everyone. We drive change in our organizations. We do innovative products that drive these platforms and convert these platforms into usable solutions where the end users basically benefits the power of it. So I believe, I want to believe that AI is going to improve everything in the future, make our lives better. I do not see this as a challenge or a risk for the workers or professionals. I see this as a tool. So I would like to invite all of you to take this forward, introduce AI into your organizations in case they have not done it. And if they have already started, please do take into considerations the warnings and the areas that you should think ahead of time rather than later. Be proactive than reactive. And hope you learned something new today. And again, thank you very much for joining this session. Have a wonderful day. Bye.
Yep, absolutely. It changed everything. But we are hoping this is for the best. So, this was the last speaker of our technical day for AI Transformation Global Summit from Geekle. We truly have the global speakers line up here because from all around the world, and that's cool. I see our great speakers on my backstage, and I invite you guys to turn your cameras on, and I pulling you in to the stage. Yes, yes, I see you. I hope you can see and you can hear me. Hello, Samita. Hello, Roman. Hello, Mikhail.
Hey,
Hi, all good.
Thank you for coming. Thank you for sharing your knowledge, expertise, and your passion to the tech. And yeah, why don't we just start from the first question, and let's go from this one. Roman, how do you ensure AI models stay reliable post migration with new data?
Yeah, can you repeat that question? Sorry, I just see the lag. Can you please repeat that question?
Yes, of course. How do you ensure AI models stay reliable post migration with new data?
Okay. So we know that whenever we are moving kind of cloud journey or any kind of ongoing scheme with any kind of migrations or any kind of simple pipelines, we know our data is always monitored. So any kind of data which is flowing as a new or any changes, it always comes as an incremental data, and our pipelines always ready with the AI monitored tools and services to watch it from the starting from the ingestions till the transformations, and it continues. And this is the reason we suggest and advise always, we don't just look at the raw data, we always look at the transformations, we always look at the production size, so that it understands the behavior, that any new data which is coming, it is also identifying the anomalies in early stages, and give us a kind of right information, and with the right thresholds, limits, and inaccuracies. So that's where continuous monitoring is always advisable with the AI tools. We have a lot of AI tools and services in the today's cloud providers world, be it AWS or Azure. In the AWS, we have AI robot, and then we have a Trifactors from the Alteryx. So lot many different tools we can use based on your company's vision, what tools and services are already available for you to use. So
Right, right,
and
right.
mostly these are available on the chatbot nowadays. So yeah, you can always continue to the
Thank you
monitoring
very much.
pipeline.
Thank you very much. Monitoring. Answer is monitoring. Yes, sure. Okay, let's go to next question. Goes to you, Mikhail. How do you optimize high performance computing workloads to balance speed and cost efficiency?
So there are numerous ways to optimize those things, but the main thing you have to suggest for your company as a both security and technology engineer or manager, doesn't matter. So there should be also a balance between business requirements and tech capabilities, right? So for example, it's possible to have a solution for I don't know, for very costly solution, right? Which could solve any possible issue around the place. But there also could be a solution where you can find a joint solutions like open source, and half of the solution would be a commercial off the shelf. While open source solution would solve most of your problems, right? The second part would generally be used for proper management of the resources, and therefore you won't spend much time on dealing with the stuff that was already done, and many companies invested in that, right? But at the same time, the capabilities, you won't lose capabilities in terms of technological stack and the opportunities that are brought by high computing power.
Sounds reasonable. Thank you very much. And next one is for Samita. How do you handle data conflicts when syncing across multiple devices in real time?
Interesting question. So, when it comes to today's world, people are not only relying on like their own single hand phone. They might have their personal mobile, they might have a secondary one, they have iPad devices and everything. So I think it's an interesting question. And for example, when you open a certain application at a certain point and you switch to your tablet, you don't want that particular application to show a different screen or something. So a good example is if you take a look into Netflix or Disney, how they sync things in real time. For example, you could be in the 20th minute of a certain episode and you jump into your iPad at the end of the day and you don't want it to restart, right? So one thing is that the application should always, when the applications are brought forward, they need to always sync up with the central servers, make sure the central repository keep a copy on the client's activity, where they are, where they stop things. So we need to keep logs real time. So it is in a certain angle, it's a little bit of extra work for the team, but in the long run, these data, the logs, could also be transformed into valuable information to check user behaviors, retrain the AI models. There's numerous applications behind this as well. So I would say this is the kind of like the beginning of how we would sync data in between systems, but it's kind of the tip of the iceberg. Of course, you want to kind of grow on that logic and kind of build a system on top of it where the rest of the episodes are being pulled up that are relevant. You understand their favorite factors or their genre, and then you kind of build the ecosystem around that as well.
Right.
So one thing that is in our favor when it comes to sync up is that not like the earlier days, data is more widely available. Sync ups are available. I remember when I started my career, we had mobile application, a category of mobile application called offline mobile applications. So there were certain regions in the world where people were not having mobile. So you were supposed to be able to download a mobile application and use it even without syncing. But I think we are way past that margin. So
Right.
again, constant sync ups, make sure the system understands the user's preferences, constant keeping of logs, make sure that the system is up to date on everything.
Right, so synchronize and analyze logs. Thank you very much. And we're going to you, Raman. How do you handle legacy systems with outdated or incompatible data during cloud migration? I believe your mic is off or something wrong with the sound because we can't hear you.
Okay. Can you,
Yeah.
yeah. Can you hear me now? Can you hear me
Yes,
now?
you are. Yes, we can hear
Okay.
you.
So this is an
Good
interesting
morning.
question. Very interesting question. We have been dealing it right now already in our ongoing projects. So this is very important to understand your data in the legacy system before doing anything, right? So as we have spoken about what your data is, let's understand the very first step for us to understand what is our data inventory. What are the data sources with us? So if we understand our data inventories and data sources at first, then the next step is just to understand where we have a problem, what kind of data inaccuracies, be it as a duplicate data, be it as a processes which is completely decomposed and not running exactly. Understand the legacies technologies, what exactly those are, and what are the basic problems we may have when we are shifting to the new technologies. It may be a simple example of rounding functionality may perform differently into the legacy technologies, and if you are moving to the Python, rounding will come into the more precisions. So knowing your data at first step with right inventory, right integrity, right accuracy, and knowing what are the major prioritized issue we have. If we keep a log of that at first, that will gives you a first confidence and a boost in your cloud migration journey. Precisely. And
Thank you for
the
your
best way
answer.
to handle that, yeah, correct.
I thought that was the end of your answer. If you need to add something valuable, please go.
Yeah, I just wanted to say that best way to handle this is ensuring we create a precise data lineage, data synopsis well in hand, so that our journey makes more smoother with this migration journey and further AI mechanics. Thank you.
Right. Thank you very much too. And Samita, next goes to you. What is the best way to prevent unauthorized data access when deploying machine learning models?
Right. So that's definitely something really practical. So in my past work, I'll just take like a really good example. We deployed self-care applications to tier one telcos around the world. And part of all the self-care applications is to have a chatbot, or you call it an agent, right? Virtual agent. So these agents are going to talk to real people, and they are going to raise questions about their bills. They might sometimes, even though we advise not to do, they sometimes share sensitive information like their ID numbers. I mean, I cannot tell enough. None of the warnings work. People keep doing that. So that's a real fact. So it's absolutely important we do not breach regulatory compliance in the region. So each region has different regions. So if you look into Europe, we have GDPR. So it's very important when you store this information, you only process and store the relevant information rather than just like a transcript of a chat. We do not want that to be processed in our language models. We just take the information based on our training flows or the algorithms we have built in. It'll just process what we require. I would say that's one thing. And then when you take the back end of the system, there are actual people, agents working on it as well. So one of the product we worked is called like an omnichannel platform. So omnichannel is that the back end, we just have like a single admin, but from the front end, people can reach it through WhatsApp, Telegram, whatever, like web chat end. So again, we need to kind of make a bridge between those two platforms to censor it. We don't want sensitive information being flowed. In the same time, we don't want how do I put it, the admin staff to be abused. And so there has to be like a nice bridge between that to censor the information coming in from security angle and from language angles.
Thank you very much.
Yeah.
Thank you so much. Yeah. And the last one goes to you, Mikhail. What are the key trade-offs when choosing between cloud-based with versus on-premise infrastructure for AI workloads?
Well, that's actually a good one. So the main points here are the following. So the first thing, it really depends on what state of your organization is right now. So in case you don't have enough resources to manage on-premise infrastructure, if you don't have enough capacity to do so, right? Because it both depends on human resources and the cost management. So, for example, in case you're in the middle between something like a startup and a small to medium enterprise, it's better for you to go with the cloud-based AI, just to avoid unnecessary costs and disruption due to maintenance. You just like offload it to the cloud provider. At the same time, you have to be cautious because when you go to cloud, be very cautious in terms of like being in a situation when you won't be able to switch clouds or move to on-premise infrastructure or anything like that. So you would be really stuck with the vendor lock, which could cause disruptions, and it's not cost effective enough for the company which grew up from, for example, small SME to medium enterprise or to huge enterprise. Well, you have the resources if it's like a medium to large enterprise, right? It really depends on scenarios you're using. Right. For example, if you need a global solution that should be available from each and every point on Earth, you definitely go with cloud solution just to avoid issues with availability, latency, and all the stuff which is crucial in terms of AI workloads. In terms if your AI workloads are located in a single region or prepared only for example, internal use, right? It's okay to use it on premise. So something like that. I would answer something like that, just to be cautious once again with choosing the cloud provider that could be dangerous in the future.
Don't you think that these small open source models they are kind of getting quite competitive with those OpenAI and other API providers? Because, well, let's say DeepSeek is not that big to maintain in your cloud or hosted version. So, what do you think about this approach? They getting smaller and smaller, actually.
Yeah, I absolutely agree with that. That open source is nearly close to the commercial versions of AI. However, open source solution require a lot of computing resources. So we've tried it within our organization. So we've deployed it in AWS, the whole infrastructure for DeepSeek, and we tested it for coding for our developers. And to compare with, for example,
that's interesting. Yes. Please go on. Right.
Yeah. So we've compared later on the price that took for the cost of the solution in AWS to, for example, cloud, CLAUDE, right? The solution for AI coding and OpenAI. And the price was similar, nearly similar, right? But the thing is that with the deployment of such tools, you have to be very cautious in terms of learning of those models, of those AIs, and where you take them, where you collect the data, right? While the OpenAI and the rest of the commercial of the shelf solution, they are like online, right? You have the online data for internally deployed software, AI software like DeepSeek and the rest, or Grok, for example, the Elon Musk's AI. You have to double check if the data is actual, and we all know that, right? After the AI was introduced, the speed of the pace with the development industry changes is like in the blink of an eye.
Right. Thank you very much, gentlemen, for joining this session. Thank you for sharing your experience and knowledge and passion and everything. We're closing this day. We're wrapping up this panel discussion. Just to remind to our audience, don't be afraid of AI. It's not there yet. You still need to work, and it's big question. Is it kind of positive ROI of using AI in many cases? So our mission here at the Geekle is to gather and deliver to you best use cases to find the real world knowledge and experience from engineers all around the world, how they actually leverage AI today with successful cases or failed cases. Doesn't matter, to give you this sense of kind of being on top of this wave and use this wave not to and see this wave not as a threat, but to use this wave as your career growth. Again, thank you very much. Thank you, Samita. Thank you, Rama. Thank you, Mikhail. Have a nice day, evening, whatever you have, and probably see you next time.
Thank you.
You too. Thanks all. Bye.
Thank you.
Ed.
Bye.
Thank you. Bye.
Okay, bye everyone. See you next time.